Good morning. Thank you everyone for being here. My name is Neil Kashkari. I'm president of the Minneapolis Fed. On behalf of the Minneapolis Fed, welcome. We really appreciate you being here, all of you. We've got a pretty full house here in person and everybody who's tuning in online. It's an exciting day. This conference has now become part of the fabric of the Minneapolis Fed. We're really proud that we're able to attract such high quality scholars from around the country and in some cases around the world to participate with us. I thought I'd spend just a minute and give you the backstory. Some of you probably know this, but on why we founded the Institute many years ago now. When I first got to the Minneapolis Fed, that was in 2016, I guess it's not surprising, the economy was throwing off some confusing signals. It usually is. At that time, I was hearing from a lot of businesses who said, we have a historic worker shortage, we can't find workers. And as I would go into lower income communities around the Minneapolis region, and actually around our district, I found pockets of labor that said, we can't find jobs. And I said, I don't understand. How are businesses saying they can't find workers, and yet there's so many workers who are either stuck in part-time jobs or can't find any work? What's the disconnect? What are the barriers? And so I pushed our economists here to help me understand that. And we realized, there are limits to our understanding of what's happening in the labor market. We knew this, but I think it became more of a focal point for us. When we look at national statistics like the unemployment rate, labor force participation rate, those are important statistics, but they mask so much complexity and heterogeneity underneath the surface. And so then we decided, let's build a focused research effort to help us understand what's happening underneath the surface and what are some of the barriers that are preventing people from fully participating in the economy. This is core, for me, this is core to our monetary policy mission. But as we examine these questions, what we're realizing is we're illuminating potential solutions that are outside the scope of the Fed. So this is not simply about equipping me and my colleagues for monetary policy. That's a big part of it. But as we do this research and we uncover these learnings, how can we help other policymakers in other realms benefit from what insights we have gathered? And so this was an experiment that we launched, 7 or 8 years ago. It's gone very, very well, better than I think maybe we had expected at the time. And we realized how much we are benefiting from it. Abby and her colleagues are regularly part of our monetary policy deliberations as we are trying to examine what is actually happening in the economy. I mean, today is a great example. We have inflation that's still too high, running at about 3%. Some sectors of the US economy look like they're doing great. Some sectors of the labor market look like they're under pressure. How do we make sense of these mixed signals? And it's not simply the research projects that are being done by folks in the Institute. It's just having that expertise woven into the fabric of our everyday discussions that we're able to lean on and benefit from. And so I'm grateful for that, and I'm grateful for everybody's work. This conference, it's an annual conference. It's our 5th year, I believe, and I think we've done a great job with Amanda taking the lead here and bringing together such expertise. This is, by design, a broad group. When we started this effort, one of the things that I said, I don't know if you all remember this, is I said, to solve some of these problems, to understand some of these problems, we don't simply need economists, but we actually need an orchestra. And so we need to broaden our lens and bring in people from a wide range of expertise to help us understand these issues. And so I think this conference is an example of that. We bring in visiting scholars that are economists. We bring in visiting scholars that are outside of economics. We have advisors who are, of course, economists, and we have advisors outside of economics. That's not by accident. That's by design from the very beginning of this, that we need an orchestra to understand some of these issues and to potentially design helpful solutions to some of these issues. And so I think this conference today is an example of that. It's very broad. It's open for submissions. We bring in early career scholars. It's publicly available, both to people within the Fed and to people outside of the Fed. And that's, again, also by design. The last thing that I'll just say is, if you sat in my monetary policy briefings with my colleagues who I've gotten to know now over the last 10 years, and they've gotten to know me, these are like, I describe them as intellectual wrestling matches. We're not yelling at each other. We're not swearing at each other, but we're challenging each other. And they're challenging me and saying, hey, they're not afraid to say, that's wrong, you've got that wrong, or we just have a fundamentally different view. I hear them, and sometimes I say, I've heard all of your arguments, I understand your arguments, and I just fundamentally disagree. And here's why. But the purpose of that is to get better and to get smarter. And so that when I go back to Washington, D.C. for FOMC meetings, I'm almost never surprised. I've heard all the various arguments that I'm likely to hear because I benefit from this environment where we're challenging each other. I think that this conference is also designed to be challenging. Again, bringing in different voices with different perspectives, different research methods. I think those are key to actually making us better and better understanding some very tricky and complicated issues that we're going to be looking at. And so grateful for your participation, grateful for you being here. Thank you to all of you. Thank you to our visiting scholars. Thank you to our advisors. All of you help us make the Institute as effective as it is. And so with that, thank you. I'm going to turn it over to Abby Wozniak, the director of the Institute and vice president in our research division, who's going to introduce our keynote speaker. Thanks.
Thanks, Neil. All incredibly well said. And as mentioned, I'm Abby Wozniak. I'm director of the Opportunity and Inclusive Growth Institute, and I'm really excited to be able to introduce David Card this morning. David Card is the class of 1950 professor of economics at the University of California at Berkeley, and he's also a labor economist who has made substantial contributions across the many, many areas that are folded in inside of labor economics. It's a very broad field. For those of you who don't know Dave's work, and I'm pleased to be able to call him Dave, as I believe we all can here today. For those of you who don't know his work extremely well, let me tell you a little bit about his major contributions. Dave is an originator of the reduced form techniques that now constitute one of the main toolkits across all areas of economics. These techniques seek to base identification of economic concepts in empirical sources, commonly natural experiments, sometimes actual experiments now. And this is in comparison to model-based identification, which is another major toolkit, piece of the economics toolkit. I think sometimes these approaches are described as camps, but I know Dave, foremost among economists, would describe them as complementary sets of tools, something that all economists need to be versed in, and we need to be able to deploy as most appropriate to the questions that we seek to answer. And part of this work, Dave has applied this across a whole range of settings. So he's pioneered empirical studies of the minimum wage, very famously, also immigrant impacts on local labor markets and the US workers in them. He's made major contributions to research on schooling, job training, unions, and wage flexibility. Again, almost no topic within labor economics going unexamined by him. And his recent work considers firm effects, place effects, and intergenerational mobility, which we'll be hearing about this morning. As you might expect, he has an extremely impressive and long list of accomplishments, which I will very briefly summarize. He's held editorships at both the AER and at Econometrica, two of our major journals. This now makes me curious as to how many can make that double claim, so maybe I'll research that later. He's been a past president of the American Economic Association, and he's a member of the US National Academy of Sciences. He was also awarded both of the highest honors in economics, the John Bates Clark Medal in 1995, which goes to economists under 40, and the Nobel in economics in 2021. More than this, though, Dave combines being a model scholar with being a model colleague. And I've heard this from everyone I talked to about bringing him in as our keynote presenter, and I've experienced it myself. He's thoughtful, he's good-humored, and he's willing to consider questions from many different angles. He's unfailingly supportive of graduate students and colleagues across the discipline. This is actually not rare, but it's not a given, I think particularly for economists of his stature, and it's worth recognizing that today, along with his many other accomplishments. So, given all of that, I'm extremely pleased to welcome Professor David Card to deliver this year's keynote address at the Institute Research Conference. After his presentation, I'll come up just to help field questions from the audience for a few minutes at the end of his presentation. Let's welcome Professor Card.
Thanks, Abby. Thanks very much for the invitation to present here. I've never actually been in the Minneapolis Fed, so I'm going to present a paper with my colleague Jesse Rothstein and Moises Yi, who's at the Census Bureau, and this is work that includes some data from the LEHD that has been disclosed. So we're going to be talking about intergenerational mobility. It's always kind of fun when you teach a topic on this kind of a topic to pull up Galton's original paper. He's the guy that invented the term regression. This is a chart from his original paper. His first application was actually to biological examples, but then he realized he could apply to humans, and he measured heights of parents. He took the average of the mother and the father, and he plotted against that the height of the children. And he did one kind of cool transformation. He multiplied all female heights by 0.92, which I was kind of doing some calculations. That's roughly correct. And he got that you're about 2/3 as tall as your average of your parents, but everybody kind of tends toward the middle. And his term for the middle was mediocrity. So his original title was regression to mediocrity. And now mediocrity to us means something different, I think, than it did in 1870. I should mention, in the 1950s, a very famous sociologist named Duncan started applying this idea, and probably most of you have heard of the Duncan Index. And the Duncan Index was a way to give a number to all occupations based on, originally based on kind of a prestige score interviewed from people and then interpolated from education and income. And they usually got slopes of around 0.4 to 0.5, and that's going to be a kind of a benchmark for what we're going to see later. In the labor market case, people started to get interested in looking at intergenerational transmission of economic characteristics. There wasn't that much data, but it's safe to say that until 1990 or so, even maybe even a little later than that, most people believed that the intergenerational correlation of income was quite small. This is data from 1986, so that's not that long ago. I already had quite a few PhD students by then. And these are, the R in the first column is the intergenerational correlation of income measured in a paper in Jolly by Curl and Pope, using income data from LDS donors. So if you're an LDS person, you're supposed to give 10% of your income. And it's widely thought that most people do. And so they could translate that. And you can see they could get it up to around 0.18, but that's about as high as they could go. Now, I was at Princeton in the early 80s and beyond, and Gary Solon was one of my grad student colleagues. David Zimmerman was one of my PhD students. This was at a time when labor economists were starting to realize that a lot of things that we thought we knew were all messed up by measurement error. And these guys figured out that this intergenerational correlation was probably significantly downward biased because the earnings that you see for a person in any given year is a kind of a lousy estimate of their average attainment. And so both Gary and David published papers in the same issue of the AER. Now, by no coincidence, Orley was the editor of the AER at that time, Orley Ashenfelder, who was Gary's and mine thesis advisor. That showed that the intergenerational correlation could be as high as 0.4 or 0.45. A few years later, Bash Mazumdar, who I think probably many of you know, he worked at the Chicago Fed for many years, had a job market paper that took a while to get published, but matched the SIP to SSN records and did a lot of very detailed calculations, including things that are still quite useful to read. So this is probably one of, if you ever work in this area, I'd start by reading this paper. A lot of stuff about like daughters versus sons, what happens if you have years of missing income and so on. Anyway, Bosch concluded that the intergenerational correlation could be as high as 0.6. It's certainly higher than 0.45 if you really take the long run view. And then what's happened in, say, the last 20 years or 15 years, I'm sure everyone is familiar with all of the work by Raj Chetty and Associates. Starting in a paper, a well-known paper in 2014, what they were able to do was they had access to IRS records, and they realized you could match children to parents because of the tax deduction records that started to be recording the child's Social Security number as of 1992 or 3. And so they were able to match massive samples of children to their parents And then they used the tax data for the parents and the children to construct IGEs across big samples. They argued that and one of the things that is probably most confusing for new readers of these papers, they have a big discussion about using income ranks rather than the logs of incomes, as we're going to do in this paper and others did. There is a kind of a useful thing to know, which is if the data are log normal, then the Spearman correlation, which is the correlation of ranks, is almost exactly the same as the Pearson correlation, which is what you're going to get from a regression. It's roughly 0.97 of the other. They're very closely related. So it's not a huge difference between those two, but it does sometimes matter, sometimes not. More importantly, Chetty et al. Found that the beta 1 in this regression up here, no, that's not going to work. The beta 1 in this regression isn't so different across states or across counties or later on across different parts of the country. But the beta 0 is quite different. And so that sort of changed the interest in a lot of IGE papers into trying to understand why the intercept is different, not so much the slope. They also showed that in later work, Chetty Hedren, a very important paper, argued that the differences in this beta 0 coefficient across different places might well be causal. And that's still somewhat controversial, but I think most people are sort of taking that at least a large part of it is probably causal. So what we're going to do in this paper is two things. We're going to extend the log-log IGE model in two ways. First of all, we're going to propose a really simple model for what's going on with beta 0. And we're going to argue that one simple way to capture differences, and we're going to use neighborhoods as census tracts. So one of the really important things to characterize the different census tracts where children can grow up is the average earnings of other parents in the neighborhood. The second thing we're going to do is we're going to decompose the child, the parent, and the neighboring parent earnings into person and firm effects using this very well-known technique in labor economics invented by Aboud, Kramars, and Margolis, where you decompose it into a firm component and a person component. We've got basically 5 key findings, 4 of which are on this slide. First of all, we're going to argue that these neighborhood parent earnings really matter a lot. So in simple specifications, the coefficient on the earnings of the parents in the neighborhood are typically as large or even larger than the coefficient on your own parents. So that's a really large effect. Secondly, we're going to argue that the mean parent earnings in the neighborhood is a pretty good summary. We're still working on that, and we haven't got everything disclosed. And as you know, there's been a little bit of a slowdown at the Census Bureau lately. But we're going to argue that that's a pretty good summary. It's not quite a sufficient statistic, but it's pretty close to what you need to know about a neighborhood. We're going to show that the person effects of the own and neighboring parents have larger effects on children than the firm effects of the neighboring parents and your own parents, but that the firm effect components matter quite a bit. And that's related to earlier work that had tried to find, for example, evidence on other components of earnings that you could argue are sort of based on luck or kind of circumstances rather than based on pure human capital. So you can think about a firm effect as something that's not really based on your human capital, but on like how lucky you are in finding a job or what's the access to a particular job. We're also going to show that the person effect components of the own parent and the neighboring parents mainly affect the person effect of kids, whereas the firm effect components of the two groups mainly affect the person and firm. So this is kind of a block diagonal structure. And then the fifth thing, which is not on this slide, is we're going to use this structure to give some new insights into differences between black and white kids, which is, of course, the major topic of interest. We're going to use data. The way we construct our families, we find all the families in the 2000 census. We take the children who are 9 to 17 living with their parents, okay? And we're going to have 2 parents if your parents are married, okay? We're going to have 1 parent if they're not. We have to use the old-fashioned rule because of the way that the families are linked. We're going to observe the census tract where you live, and we're going to then link both the parents and their children to later data from the LEHD, which is based on unemployment insurance records for where people work. So this is giving a little bit more detail. And for example, imagine we have a kid age 13 in 2000, right in the middle of our age range. And suppose their parent was age 25 when the kid was born, which for people in this room would be quite young, but for the typical person is about average at this time. So we're going to see the parent when they're in the years 2003 to 2007, We start in 2003 because the LEHD data doesn't really, there's a lot of states missing until then. When the parent is in their 40s, we're going to see the kid in 2018 to 2023 when this kid would be 31 to 36. So getting to be the place where they're starting to be closer to the, if they're getting a PhD, they might have their first job by now. We're going to do something a little unusual. We're going to take another interval of data from 2010 to 2014 for the parents, and we're going to use that as an instrumental variable for the earnings of the parents in 2003 to 2007. And that's going to address this concern that Baj Mazumdar raised in a lot of his work, which is surprisingly, even like 4 or 5 years of earnings data isn't enough to get rid of some of the averaging problems, particularly when parents aren't quite the right age range. We're going to do one other thing that's maybe a little unusual. It's different than what Chetty et al. Have done, which is basically looking at family income. We're going to use for parents the earnings, so this is wage and salary earnings, of the highest earning parent. Okay, now we've done lots of other stuff and I can tell you a lot about that, but it turns out that's not a bad approximation to something like the socioeconomic status, or I would argue the socioeconomic status of the family. Okay, and then we're going to use the earnings from the LEHD of the child. But we're only going to use the earnings when we see that you're earning at least $3,300 a quarter. So we're going to try and throw out quarters where you're not working more or less full time. And our idea is we really want a proxy for something like a measure of earnings capacity. Okay, so we're thinking of this more like a labor economist than like somebody who's interested in the general characteristics of families, like how much do you participate in the welfare system and things like that, which would of course obviously affect intergenerational correlation, and there's quite a lot of interesting work on that. So we're thinking more about trying to use these models to think about the intergenerational transmission of earnings capacity. And that fits it better with our AKM framework. So we start with a sample of about 30 million kids who are 9 to 17. We're going to basically only use white and black kids. That means that almost all of our kids are born in the United States. So we almost have no immigrants because we got rid of Hispanics and Asians. We have to have one parent in one of the right windows, in both of those right windows of time. The kid has to be in the right window of time. They all have to be picked, so they have to have a way to link their data. So we start with 30 million. We end up with 5 million observations, but we have some data on bigger subsamples just to see what matters. Doesn't matter too much for what we're trying to do. So here's a kind of a summary of the data that we start with. To the left, the two columns, those are just based on the public use samples from the 2000 census. So think of that as adults in the 2000 census who have a kid in our age range at that time. Okay, so those would be potentially our parents. And over here on the 3 right columns are from the LEHD and the census combined. So we start overall, if you just have white and black kids, about 20% of them would be black. But if you restrict to kind of higher earning parents, you're going to be closer to between 10 and 15%. About 80% of these families are married couples, especially of the higher earning, but that obviously is quite a bit lower for black families. It's only about half among black families, as probably most of you know. In our overall samples, only most of them work a little bit, but we're going to impose the restriction that people work more than $3,300 a quarter, which is kind of close to $15,200 a year. And so they're going to have family earnings of around $55,000 a year at that time. So a little bit above average. If you look down here, this is what we're going to see in the later data for the earnings. So the parents are earning around $55,000 in 2003 to 2007. Those were the boom years before the Lehman crisis. Then they're going to earn about $65,000 in the bad years, 2010 to 2014, where we were still arguing about whether we should be fighting the recession or not. And then the kids are going to be earning around $60,000. Now the kids are quite a bit younger than this, so that's probably most of the reason why they're lower. And you can see some black-white gaps, which I'll bring up at the end. So to start with, here's the first fact of our data. If we take those samples, that 5 million observations, and run a regression of the mean log earnings of the kid in this period, 2018 to 2022, on the mean log earnings of the parent, we get a coefficient about 0.29, which is a little low. But remember, we're kind of conditioning on people that work These are full quarters, so this is like the intergenerational correlation of wages, is the way to think about it, I think. If we instrument that coefficient in column 1 with the earnings in the later period, we get it up to 0.32. So there is a little bit of attenuation bias, and so everything from now on is going to be instrumented. And then finally, if we include fixed effects for each commute zone, where the family was observed in 2000, that drops it down a little bit. And of course, that's because a couple of points of this intergenerational correlation are because, on average, most people live very close to their mother. Again, not so many people in this room, but most people. And that means that you inherit your parents' good or bad labor market. And that's a fairly large component of earnings. But even with all of that, you're getting around 10% R squared. So you're not really explaining a huge amount of the variation. There's a lot of idiosyncratic variability left. OK. This is what the log-log relationship looks like. And there's two samples here. Our main analysis sample is the orange one. The main thing that restricting with adding all these restrictions about having all that extra earnings just kind of raises the whole thing for the children. But it doesn't change the slope very much. The slope is similar for white and black children. This is a fact that's recovered in one of two of Chetty et al.'s papers about black and white differences, that the slopes are remarkably similar, but the intercepts are obviously much higher for whites than blacks. So it's not the case. It's kind of shocking in some ways. It's not the case that you have, if you're a black person and you have a high-earning parent, that you get equivalent to high-earning white people, which you might have thought if you grew up in university town or something. That's not true on average. The gap kind of persists. And here's the rank-rank relationship, which is a little bit flatter and a little bit less linear. So we're going to use the log because we want to decompose everything, and AKMs obviously works in logs, and decompositions don't work in ranks. OK, now the next thing we're going to show is how much neighborhoods matter. So we start in column 1. That's our 0.295 coefficient. In column 2, we do something kind of weird. We basically run a regression of the kids' earnings on the average earnings of everybody, all the parents in their tract. OK, so the way we're constructing this tract level variable is we take all the kids in that tract. We're restricting our tracts to have at least 20 kids of interest. And we take the mean earnings of all the parents of those kids. So these are sort of the parents of the kids that you would hang out with. That's kind of our conceptual model. And you can see now that we're not including your own parent there, so you get a coefficient of almost 0.5. Okay, so that's getting up to Bosch level numbers. Okay, pretty high. Now, if you include separately the parent and the tract average, it's going to split that 0.48. You can sort of show, sit on a piece of paper and play around with it a few minutes. It's going to break it out into the two components. They're going to add up. And you can see that actually the coefficient associated with parent earnings is a little bit smaller than for the other parent earnings, which is kind of shocking. And I have to say, the first few times we did this, we thought we'd screwed it up. But that turns out to be, I think, correct. So there's a very large effect of that. It doesn't matter too much. Those two coefficients don't change too much. If you include other things like whether the kid is black, there's a big negative coefficient there if the kid is black, obviously. We saw that in those regressions. If the kid is male, obviously males earn more than females. And if you're looking at earnings rather than wages, the gap is even larger. If there's a single parent or if both parents are earning, these two coefficients, those coefficients aren't very important. Okay? Now, you might have thought they were, because you might have thought what I really should do is be regressing kids' earnings on the average of their parents' earnings, like Galton did, or some kind of sum, or something like that, more like what Chetty et al. Did. But if you're trying to predict wages, it turns out you're better off actually trying to predict it with the highest earnings of the two parents, for a variety of reasons, I think. I'm going to come back to column 3 later. So basically, that seems to be a pretty robust 0.2 something. Now, neighborhoods can matter for a variety of reasons. So we're not trying to make a claim that this is entirely a causal effect for a variety of reasons, including, most importantly, here's the way to think about it. Suppose your parents are trust fund babies. Okay? I live in Berkeley, so we have trust fund babies. There's still such things. They mostly live in California. So they're living in a neighborhood where everybody else is earning a lot, and they just like volunteer. Okay, so actually, I have neighbors just like that. And so it's going to look like they're kind of poor. And so that would be one reason why the neighborhood earnings would matter a lot, okay? So you might be worried about those kind of things. You could imagine that there's also direct effects of neighborhood earnings because it's working through mechanisms like higher income families in the neighborhood, support a better school system, or support more cultural things. Probably those are much more important mechanisms. So what we're going to do in this next slide is we're going to take we're going to run a regression of kids' earnings on parent earnings, a dummy for are you black, a dummy for are you male, and a dummy for are you do have single parents, so 3 other control variables, and then a tracked fixed effect. So that summarizes everything about the track that's important for kids' success, okay? And then we're going to take the tracked fixed effects and regress them on stuff. And we're going to try and see what summarizes or what's important in explaining differences across tracts in outcomes of kids. And so you get a 0.2, which is kind of mechanical because that's sort of what we started with. If you just included fraction black and fraction male in the neighborhood, fraction black would be pretty strong negative. So black neighborhoods on average are not as good for kids. But surprisingly, in column 3 and column 4, if you include also mean parent earnings, you notice that the fraction black coefficient actually goes slightly positive, but weak, okay? Now, most of this sample is white, right? 90% is white. In fact, if you only do this for whites, it's also the case that on average, if you control for mean parent earnings, growing up in a neighborhood with more black kids present is not a negative thing, okay? So that's kind of an interesting fact. Growing up in a neighborhood where there's more boys is a little bit negative. Now, all the women in the room can have long stories about this. I'm sure there's many traumatic episodes from high school and middle school that we could all relate to. Growing up with more single parents is a little bit negative, even controlling for negative, but the employment rate, for instance, doesn't matter. So again, we don't have the R-squareds. When there's an adjusted R-squared you could do for this kind of regression to say how much of the actual variation in the tract effects that's not sampling error, can you explain? It's around 75%, but you didn't hear that number from me. Okay. The last thing we're going to try and do is this AKM decomposition. So you run this giant AKM. I'm out of time. You run this giant AKM decomposition. I'll just show a couple of slides. So this is decomposing the child's earnings into a person effect and a firm effect. So column 1 is the regressions we start from. Now, because child earnings sum to the person effect and the firm effect, the coefficients in column 1, 2, and 3 in row 1 add up, okay? And you can think about 0.034 divided by 0.225. That's kind of the share of the earnings of this component of parent earnings that's contributed by that adds into the outcome of the firm effect of the kids. And it's around 10 to 15%, which is pretty similar to what you often get in variance decompositions of AKMs. Interestingly, that's also true for the other parents in the neighborhood. So the other parents' firm effects also matters at about the same magnitude. In fact, if you look here, the verticals here, these two coefficients are the same, and these two coefficients are the same. Kind of interesting. And then the second thing we do, now we're going to take the earnings of the kid, and we're going to run a regression of them on the parent person effect, the parent firm effect, the tracked mean parent person effect, and the tracked mean parent firm effect. And notice that the coefficients on the firm effect components are about 0.1. Person effect components are about 0.2 to 0.22. So these are smaller than these, but still pretty big. So growing up in a neighborhood where the other parents have kind of high wage premium jobs is good for you, okay? If we decompose it into how that translates into the person effect and the firm effect of the kids, you can see there's a very large effect here, very large effect here, and similarly up above. So it's kind of mainly on the diagonals. So the parent firm effect is affecting the kid's firm effect. The other parent's tracked mean firm effect is affecting the kid's firm effect, and similarly for the person effects. I don't have time to talk through all of the possible explanations for that, but it does suggest that if you think of the person effects as largely capturing what would be in a human capital model, it does suggest that there's something else going on besides pure human capital. Finally, since I'm out of time, I'm not going to say anything about this, but there are some interesting implications for black-white differences. Parent mean earnings in a tract are quite a bit lower for black kids, even controlling for their incomes, which is kind of a well-known fact if you dig carefully. And so that explains part of the difference in black-white income of children is explained by the parents' earnings, and part of it is explained by the neighborhood earnings. None of it works through firm effects. Black people in the United States, parents, children, and other parents in neighborhoods all have about the same firm effects as white people. So there's not a distinction controlling for the person effects that people have. There's not really like a shortfall in the ability of black people to find jobs at higher premium workplaces. And that's consistent with earlier literature suggesting that on average, in fact, black people are more likely to have union jobs than white people, which is still true. Okay, so that's, I'm going to stop there, and I'll take some questions.
So my main job is just to get us started with questions. So I'll offer one, and then we can turn it over to folks in the audience who I'm sure have quite a few. So much in there, and we made you summarize it in a very short amount of time. So feel free to ask questions along the lines of just say more about that. That'd be great. But I think what I was struck by in trying to think about the role of other parents in shaping kids' outcomes later is that, at least to my mind, I haven't heard a lot of discussion around the role of parent supportive policies and how those might ultimately shape neighborhoods and communities around kids. And I'm kind of throwing this at you. This is the first time I've thought about it, is today. But I wonder if you've thought about that policy angle in kind of contrast to some of the other ways of harnessing place effects that have been discussed in policy settings.
No. Short answer, no. Interesting. I guess the main family policy that one might think about might be the EITC, which we wouldn't measure directly from LEHD, but which we could probably infer from LEHD. That might be interesting. What you probably need for what we're most interested in would be things that differ across places substantially. Are you thinking of some specific component that has a pretty important geographic variation? Do we have such things?
Maybe. I think I'm foreshadowing a paper we're going to see later today, but I'm thinking of things that keep higher earning parents in neighborhoods that they originate in through more attractive schools or whatever it is that shapes their decision to be in their original community or move out as they start earning more.
Oh, I see. Well, for sure, I think there's a lot of differences. One thing I didn't get to show, you might, if you're thinking about this, a little bit more deeply, the first thing you might say would be, well, the census tract's pretty small. There's only like 4,000 families in a census tract, and so maybe that's not, and that's smaller than a school district. So maybe what's relevant is, in fact, a little bit broader area. So what we did was we took, you can match geographically all the census tracts around a census tract. And so we include, as an additional control variable, the mean earnings of the kind of the donut around your census tract. And I thought that might knock out at least half of the neighborhood thing, but it doesn't. It only knocks out a very small amount. So it does look like it's something quite direct about the parents in the neighborhood. And actually, a long time ago, Jesse and I had a paper where we tried to look at the importance of schools versus neighborhoods and children and the relative SAT scores of black and white kids. And we concluded, much to our surprise and puzzlement, continuing puzzlement, that it was more neighborhoods than schools that mattered. And so this result is very reminiscent of that.
Neil.
Thanks for your presentation. Are the parent effects, Is this distinct than just peers? I mean, if you grow up in a neighborhood and all your friends are going to go to college, you're more likely to go to college because those are the expectations that you have with your friends. Is it the same effect that you're capturing, or is it something different?
It could be. In the peer effect, the peer effect literature is a well-known morass. Many, great ideas come to die there. But the main problem you have with peer effects is it's very difficult to identify the effect of like the other kids in your cohort all going to school. You can more credibly identify their parents' effect on you. And so this is a model where we're measuring kind of the effect of your friends' parents on your outcomes. And we're showing that they're very large. So presumably, you could set up a causal model in which some of that is an effect that arises because you and your friends jointly decide to do something. That's called an endogenous peer effect. But parsing out that part versus, you grew up and your friends' families all thought they should go to college, and they were all applying to college, so you thought, well, I better apply to college. So it's not really that like it was like a I only did it because they did it, but rather because their parents told them to do it and I was in the room at the time. I can give a lot of examples of this kind of effect from my own background. So I grew up in a very low-income rural family, but I managed to go to a pretty good high school. And so a lot of my friends in high school, their parents had good jobs. And they got me good jobs. So I got to work in a steel factory because one of my friend's fathers was an executive in that company. And I got to work at the nearby university research farm because another one's friend was those jobs. So that was a kind of another mechanism that could matter. So I definitely am a strong believer that there's some kind of background effect. Whether it operates because of the decision of the other kids or directly through the parents is really hard to know. Yeah.
So let's tee up some questions. We have some mic runners, and I'm one of them even, so.
Oh, great. Okay. Thank you. I'm Andrew Goodman-Bacon at the Institute. How important is it to be measuring and interpreting the effect of other parents in your neighborhood? And you're kind of talking about channels that go through the parents and then the kids and then interactions versus just other people in your neighborhood. Like, for example, what if you had just taken non-parents in the census and done their income or their firm and person effects? Do you think, or have you checked if that would matter as much as the parent sample?
We've started to work on that. The way we've approached it to start with, because it's going to be, you're going to think of this question in one more second, is imagine you're a black kid growing up in a neighborhood, and you could stratify the other parents into the white and the black parents, and you could say, if I'm a black kid, do I get anything out of the white parents, or do I only get something out of the black parents? So that's what we're working on to start with. When I showed those results with employment rates, that's the employment rate of the overall census tract. And so the reason why we did that is because in one of the Chetty et al. Papers, that turns out to be, they argue that's a very important variable. But in our setting, the income of the other parents knocks that out completely. So. Yeah, so we haven't done too much. We've got a few characteristics of the neighborhood. We've got the full 2000 census count, so we can get everything that was going on in 2000. We could link, to the LEHD, some of the other dudes who were in that neighborhood who didn't have kids. I guess we could do that. We haven't done that yet. Yeah, we're probably going to do the separation of the types of parents first. Yeah. The paper's already 1,000 pages long, so this. Another 2,000 isn't going to hurt, yeah. Yeah, go ahead.
Hi, Brian Stewart from the Philly Fed. I was wondering if you've done any more work than you described on understanding like what types of jobs are helpful for children. You were telling a story where jobs that young people could work at, but that might be very different from jobs, like law firms, for example, or other professional jobs where we think maybe it's through role model effects. So just wondering, I know the firm fixed effects capture some of this, but I think in the LHD you could do a lot more in terms of the types of people that are working at different firms or different establishments to pack that apart.
Yeah, the most we've done on that Brian, is you can break down firm effect into a CZ component, so there's like an average pay premium for a city, an industry component, so there's an average pay premium for an industry, and then whatever's left. It's sort of all three, but probably the within industry and within CZ is the largest of the three, which in our other work, we've sort of thought about it as kind of like how far up the hierarchy in that industry, in that city are you? So you're working at, in the retail sector, you can start working at 7-Eleven, and then you can move up a little bit to Walmart, and then you could do, if you're really lucky, you could get Costco. Or in this town, you can go to REI, that's a really good retail job. Yeah.
Hi, Lois Miller, University of South Carolina. Going back to this story about your friend's parent getting you a job, it made me think about how much of this is coming through network effects. And I think identifying the whole network effect would be difficult, but you could get just this very specific channel of, do you see individuals working at the firm of their friends' parents, and see how much of it is coming through that?
Yeah, we have done that, actually. I have that on a slide, but I blasted through that because I didn't have very much time. So some of it is actually you work at your parents' firm. And there's a pretty interesting paper from Sweden by Francis Kramars and Oskar Skans that had shown that in Sweden, now Sweden is, different labor market, right? So in Sweden, it's sort of like if your dad worked for Volvo, you get to work for Volvo. That's the way to think of it. In the US, now these firms are different. Now, first of all, they're not firms, they're establishments. And secondly, we're looking at 15 years later. So if you know anything about establishments in the United States, 15 years later, less than half of them are left. The better ones are left. So the ones you really prefer to work for survive longer. But if you do that about 6 or 7% of children have at least 1/4 of work at a firm that their parents worked at. And so that lowers it a tiny bit, but not too much. So if you throw out all the parents that work. We've also looked at, do you work at firms that the other parents in your neighborhood work at? That's a little bit more common. It seems like that might be an interesting mechanism, but we haven't got that sorted out, and we certainly haven't got it disclosed. Yeah.
Or even industry.
Yeah, I don't think the industry thing is going to matter too much, because it's a little bit, a couple of percentage points, because we've definitely done that. And the industry, maybe you could classify the industries more finely. We've been working with the 22 or 23 industries so far. You can go all the way to as many as you want. Yeah. We don't have occupation, obviously, which I'm surprised somebody hasn't asked me about that, since there's an obsession these days with occupation. Yeah.
Got time for one more question.
All right, we did it. We shut them down.
I'll close it out. I'll give you an opportunity. I know you were close on time, so I'm wondering what you wanted to add on kind of results about the black-white earnings gap that you didn't get to say. Maybe biggest surprise or biggest takeaway.
Well, there's a couple of things that if you read the Chetty and co-authors' papers closely, you can find. One thing is that the black-white gap for our children is quite a bit smaller than the black-white gap for their parents, so that's important. You might have thought black-white progress in the U.S. had stopped. There's sort of a paradigm about that, but it doesn't look so bad. Another thing that we show, if you just look at the effect of parents on children, we saw the graph. The effect of parents on children is parallel for blacks and whites, so there's not a lower intergenerational transmission. And similarly, the average effect of neighborhoods is fairly similar for blacks and whites. It's a little bit smaller for black than white, which could be because of this mechanism that there's segregation amongst the people you hang out with. The industry and CZ components work in an interesting way. So if you run a regression of black-white differences in the U.S. and include CZ effects, they get bigger. So not smaller. So the CZ effects, it's because black people tend to live in slightly higher wage places. And so on the average, if you control for community zone, you actually, it erases the black-white differences that you're trying to decompose, both of the children. And so that's probably an important thing. If you're studying these kind of things, you probably don't want to compare, across the country because they're just so different.
Amazing. Thank you.
Okay.
All right, thank you, Dr. Card. That was a wonderful start to our day together. We'll take a 5-minute break right now, and I know it's standing room only. There's lots of space next to me, but we'll resume in 5 minutes with our research program. research program. So the purpose of our convening today is to discuss research that puts people at the center of our thinking about the economy, to explore how the distinct circumstances and differences of individuals and families, individuals running businesses, individuals as workers and as consumers, how the circumstances of all individuals in our society help shape the economy and inform the work that we do. This conversation is right at home at the Minneapolis Fed. This is where heterogeneous agent macroeconomics really took root. I know that's a lot of syllables, but what it means is that we recognize the economy is not just an abstract aggregate. It's a system made up of unique individuals whose differences drive how the whole thing operates. This people-first approach to economics makes a lot of sense, but it isn't easy. People are complicated. Our understanding demands that we draw insights from every available tool: rich data, rigorous theory, and perspectives from beyond economics itself. Today we will hear a range of perspectives on these very issues. I also want to mention that tomorrow we're going to convene again offline to welcome early career researchers for a workshop. It's a unique event where we're going to engage in their newest, rawest ideas and offer guidance on advancing their work, in particular in ways that will be useful to sharpen our grasp of the questions that matter to us the most. But for today's session, so for today's session, let me explain the format. We'll have a paper presenter, which will last 25 minutes, followed by a discussant, which will last 15 minutes. And then we'll have 10 minutes for Q&A. It's my understanding that people online can also submit questions via Pigeonhole, and we'll help weave those into the conversation as well. But the last thing I'd like to do is I'd like to thank the program committee for assembling our program today, and a couple are going to help moderate the sessions, and I'll help moderate the sessions as well. So without further ado, let's get started. Our first presenter will be Nathan Hendren of MIT, to be followed with a discussion from Vicki Bogan at Duke University.
All right. Wonderful. So thanks so much for putting me on the program here. It's really a pleasure. It's a pleasure to follow David's very nice discussion on intergenerational mobility. I think you'll find some related themes here. We're going to talk about credit access in the United States. This is joint work with a really wonderful team. Trevor Baker, Eric English, Jamie Fogel, and Dan Erbst are all economists. Stephanie DeLuca is a sociologist at Johns Hopkins. And the motivation for this work is that there's a lot about our backgrounds, things that we don't choose, like how much money our parents make, our race, where we grew up, and these things affect our outcomes in adulthood. And access to affordable credit is an often hypothesized pathway that you could use to overcome your starting circumstances, maybe buy a house, get a car, invest in your education, maybe just smooth consumption. And so this raises the question then of how does one's background, things like your race, your class, your hometown, affect your access to credit, and why? Now, there's certainly been some work on this topic, and some of which I'll talk about along the way, but often this work is limited by a data limitation. There's not much data that links the credit aspects of our lives with other measures of things like income or demographic information. There's some work by the Fed Board of Governors from about 10 years ago that linked race information from the SSA to credit reports. I'll talk about some of that work. There's also some nice recent work using LEHD data, some work using mortgage application data, but nothing really at a population scale that lets you really unpack the mechanisms of the determinants of credit access. And so what we wanted to do in this work is we construct linked credit bureau and census and tax records for more than 25 million individuals in the United States. We have two samples. We've got a population sample of 1% of everybody in the United States. We also have what we call an intergenerational sample. This is a full sample of everybody born between 1978 and 1985. We've linked those people to their parents and measured intergenerational income mobility of the papers that David was referencing in the earlier talk. For a 10% sample of those parents, we also have their credit reports as well. Now, the census and tax data gives us measures of race, income, education, and place. The credit bureau data gives us person-level attributes files pulled every 4 years from June 2020, or June 2004 to 2020. This gives you a 7-year look back in each snapshot of measures of balances, bankruptcies, delinquencies, number of trade lines, all broken out by the type of credit that people have, be it credit cards, mortgages, auto loans, student loans. Now on that file, we also have a credit score. Namely, we have a Vantage 4.0 score, for those of you that know what these scores are doing. They are aiming to predict the likelihood of a future 90-day delinquency. So we're going to use that along the way as well. I'm going to structure the talk in 2 parts. First, we're going to think about a measurement question of trying to measure differences in credit access by race, class, and hometown. We're going to use the credit score as our primary measure of credit access. This comes with sort of some pros and cons. We'll talk about some of those potential cons and argue that this is a pretty good way of measuring credit access. We'll also look at the relationship between credit scores and the future 90-day delinquencies those scores are trying to predict, to try to assess whether or not those are aligned or whether or not there's any potential algorithmic bias embodied in those scores. In the second part of the talk, we're going to try to understand the determinants of credit access. What is driving the disparities that I will show you in part 1? And we'll really try to understand the relative roles of things like income relative to things beyond income, in particular focusing on roles of childhood, environment, and factors that are shaping repayment, conditional in income, and adulthood. Okay. We're related to a broad set of literatures. I just see Kyle coming in, who's got some work that will be related on the intergenerational mobility in the 4th bullet point. I got you, Kyle. But really a lot of different wonderful work in this space on measurement of disparities in credit access, algorithmic fairness, racial wealth gaps, determinants of credit market behavior. I think we're most closely in our ultimate conclusions related to some of this work that'll also be related to some of the stuff that Vicky has written on, and I would imagine we'll talk about in the discussion, and also on racial bias and lending and credit decisions. Okay, so let me just start with a statistic of who has a credit file in the United States. So we designed our sampling frame where we're able to assess what fraction of people in the US Census have a credit file. You're looking at this as a function of the age of individuals and their race here. And what you see is, we were kind of surprised by this. By age 30, over 90% of people have a credit file in the United States, and it actually doesn't vary much based on one's background. The kind of biggest outlier we were able to find is American Indians, where you see about 87% of 30-year-olds have a credit a credit file. What does vary pretty dramatically across one's background is the scores that are assigned to those files. So this is showing you average credit scores. This is a Vantage 4.0 score for people of different races as a function of their age. Asian individuals have the highest credit scores, followed by white, then Hispanic, American Indians, and Black individuals. And these differences emerge very early in the life cycle and then persist. So you see gaps between Black and white individuals of about 95 points at age 25, all the way up to about 92 points once you reach age 60. Okay, so for those of you who don't know what a credit score is or aren't really familiar with the lingo, another statistic you can have in mind is that the median Black borrower in the United States is classified as a subprime borrower in the mortgage market. The median white borrower is classified 2 levels up as a prime borrower. They would get access to generally the lowest interest rates in the mortgage market. So these differences are quite large. It's a difference between whether or not you can buy a house. Okay. These are differences by race. Now I want to turn to the second dimension of heterogeneity that we're interested in, which is differences by your parental income background. So I'm shading here the ages that we can link into our intergenerational sample, where we have not just the 1% sample, but the full sample of the United States population. We link them up to their parents, and we can study how does the credit scores vary with one's parental income background. So here we have parental income on the horizontal axis. This is your parental income percentile in the national income distribution. On the vertical axis, plotting the average credit score of these kids. You can see about a 130-point increase as you go from the bottom to the top of the parental income distribution. Similarly, for Black individuals, you see about a 100-point increase when you go from the bottom to the top of the parental income distribution. But at any given level of parental income, there's about an 80-point gap between Black and white individuals. American Indians and Hispanic individuals fall in between Black and white individuals. Asian individuals have higher credit scores throughout the parental income distribution, especially when you go down to the bottom regions of the parental income distribution. This last fact, in a statistical sense, is driven primarily by immigration. If you restrict to native-born mothers, so people whose mothers were born in the United States, you see Asian and white individuals look a little bit more similar and conditional on parental income. Okay, so those are the first two dimensions of heterogeneity, race, parental income. I want to turn to the third dimension of heterogeneity that I want to look at, which is where you grew up. And so to do this, let's stay focused for a second on white individuals, and let's pick a particular level of parental income. Let's take, say, the 25th percentile of the parental income distribution. This is about $25,000, $30,000 if you want to put a number in your head. On average, those kids will have a 660 credit score in the United States as a whole. I want to ask, how does that 660 vary based on the county in which you grew up? Okay, so let's assign that back to the county in which you grew up and ask, how does that 660 look? So here's a map of this, and you see higher credit scores in the Midwest and in the West and in portions of the Northeast. You see lower credit scores in the Appalachian regions and areas of the South. Of the 100 largest counties in the United States, low-income white kids who grew up in Brooklyn, New York have the highest credit scores at about 719, in contrast to Indianapolis with the lowest credit scores at about 629. Now, all of this data is available publicly now on the Opportunity Atlas at opportunityatlas.org. You can play around with this, look at different levels of parental income, look at different races, et cetera. Now, the last fact that I want to leave you with when it comes to differences in credit scores is the following. There is enormous persistence in your credit score within an individual over their lifetime. The way to see this is in the far left here, we're binning people into quintiles based on their credit score in their late 20s. And then holding those people fixed, looking at the average credit scores of those groups as you go forward 12 years. And what you see is some mean reversion, but not that much. A difference of about 134 points remains about 122 points later in life. This is very different than what you would see if you did this, say, with incomes, where you see a lot more mean reversion over time. Okay, so to a large extent, these disparities, the differences that we're observing emerge early in the life cycle, and they persist even within an individual over time. Okay, so we're using this credit score as a proxy. I want to argue this is a proxy for credit access, basically the price of credit that you would face in the market. How likely are you to be able to get a mortgage and things of that nature? One concern you might have on your mind is that this could, in principle, also reflect differences in credit demand. So for example, if you're in a group that just doesn't have a need for a credit card, maybe you never got a credit card, you never built a credit history, now you're pooled with some other people who have a higher likelihood of delinquency, and now you're shut out of the market and have lower credit scores. So we present a bunch of evidence in the paper that we don't think that is at all what is going on. I list some of those evidences here. My favorite stats are the bottom two here, number 5 and 6. If you just go to surveys and look at the same demographic subgroups that identify as that have lower credit scores, they report being less likely to be able to get $2,000 to cover an unexpected need, and they're much more likely to be relying on alternative sources of credit, things like payday loans and pawn shops. So it doesn't look like this is really a difference in demand for credit. This is really the differences in the availability of supply of credit to these individuals. Now, one natural reason, if you were a lender, that you would restrict the supply of credit to somebody is that you're afraid you're not going to be repaid. And so that is, in principle, what I was arguing at the outset. That's what the credit score is trying to help understand. It's aiming to predict whether or not you're going to experience a future 90-day delinquency on the equilibrium stock of your debt, with the idea that that's useful for a lender thinking of providing a marginal amount of new debt. That might be a useful source of information. Now, what I'm going to show you here now is to what extent do we see similar patterns when you look at the delinquency outcomes relative to what we were seeing with credit scores. And so let me show you this now by race and age again here. I'm going to plot on the vertical axis the fraction of people that experience a 90-day delinquency in the last 4 years as a function of their age. And what you see is that by age 30, over 70% of black individuals have a 90-plus day late payment on their credit report. That is twice as many as white individuals and 3 times as many as Asian individuals, with Hispanic and American Indians falling in between black and white individuals. So very large differences in delinquencies across these different racial groups. You see similar patterns aligning by parent income and by geography, aligning with the differences in credit scores that I was showing you. What are people falling delinquent on? Some of you might have mortgages in your mind. That is not at all what is going on here. It is far too young for people to be owning houses and falling delinquent on mortgages. What is going on primarily is what's called non-medical collections. That's the green line at the top. You should have in mind falling behind on phone bills, cable bills, utility bills that get sent to collections and show up on the credit report. The next most common thing are medical collection items. You didn't pay a hospital bill, and they sent it to collections on you. Then we get into student loans and credit cards, which are down there in orange and green, followed by auto loans. And mortgages are down here at the bottom. It's not really comprising the majority of these delinquencies. These are really you should have in mind phone bills, utility bills, cable TV bills, things of that nature. Okay, so these differences in delinquencies are qualitatively aligned with the differences in credit scores. I want to now get a little bit more precise to try to assess, is the prediction biased in a sense of, is it accurately predicting the differences in delinquencies across different groups? There's a growing recognition that even though the credit score itself is only based on information in your credit file, it's not using your parents' income, it's not using your race, it's not even using your location, but there's a growing recognition that other things in that data set could in principle be generating unwarranted disparities. So we're going to assess what's called calibration bias in the data. Before I get into what I'm going to show you here, I just want one caveat that we're going to assess the calibration bias or the bias embodied in the credit score itself. If you want to think about racial bias or other forms of bias in markets, a lender will often combine the score with other information. They could generate forms of bias in the actual markets that we observe that could go in directions that are different from the bias that I'm going to show you in the score. Nonetheless, I think it is critical to understand whether or not there is bias in the score. I just want to provide that caveat in context for what I'm about to show you. So I want to ask, conditional on the credit score, are there differences in future 90-day delinquencies by one's background? Now, just to set the stage, I mentioned there has been some earlier work on this. This is a graph from the Fed Board of Governors back 20 years ago that plotted at this time, a TransUnion-based score and looked at the future delinquency outcomes by race. And they actually did find some evidence of higher delinquency rates for Black individuals and Hispanic individuals relative to white and Asian individuals. Now, this was 25 years ago. Fast forward, the Vantage 4.0 score that we are using in the user guide for this score, Vantage actually argues that they do not see any evidence, at least for what they can do, of any form of this calibration bias. So they use zip code imputations of racial shares to try to assess whether or not there are different future delinquency rates as a function of one's background, conditional on the credit score. However, I showed you geographic variation in the credit score outcomes as well that could potentially confound a zip code style imputation. So we're basically going to go do this exact regression down at the individual level. All right. So what do we see when we do this in our data? On the horizontal axis, we have our baseline credit score. We look forward then to find an incidence of future delinquency. And now I'm plotting the future delinquency for white individuals, so higher scores, lower rates of future delinquency. We now can see that for Black individuals. And what you see is conditional at any level of the credit score, there's a higher rate of future delinquencies for Black individuals. At the median credit score of 660, it's about a 14 percentage point difference in future delinquencies, or about 33% higher future delinquencies. Asian individuals actually have lower delinquency rates than white individuals, and Hispanic individuals fall in between. So in this sense, the credit score itself is understating the true differences in the delinquencies that it's trying to predict across one's background. We find similar patterns by parental income and similar patterns by geography. The score is, in a sense, understating the true extent of these differences in delinquency outcomes across groups. Okay, so a lot of things one could do from this point. What we take away from this analysis is that these differences in these underlying delinquency outcomes, these 90-day plus late payment outcomes, are a fundamental driver of the differences in credit access across groups. Lenders are perhaps afraid to offer credit to people for whom they are afraid they may not get repaid. And so we want to turn in the second part of the talk to try to understand what are the drivers of these differences in delinquency rates. And we want to orient that around a couple of different theories. The first theory is very much related to the kind of intergenerational mobility literature that we were discussing with David's talk, which is there's large differences in income and wealth by race, by parent income, and by where you grew up. And in fact, those align qualitatively very well with the differences in the credit score outcomes and the delinquency outcomes that I was showing you before. So one natural hypothesis is that income is the mediating channel driving these differences in credit access. An alternative hypothesis is that differences in your childhood environments, things that you are learning in childhood, are shaping how you are choosing or setting up your life or facing different situations in life that, conditional on a given level of income, you might have different repayment experiences and likelihoods of repaying or falling behind on your payments. Okay? So those are the two theories that I broadly want you to have in mind. If you want to put it in a statistical type of a framework, we're thinking of an incidence of repayment. 1 minus a delinquency outcome is a function of of incomes, or maybe an income stream, childhood inputs, and other shocks. Okay? And we want to try to understand something about what this might look like. Okay, how are we going to get after this? We're going to follow two strategies. Neither are going to be perfect, but I think they're going to hopefully paint a bit of a picture here from what we can do. The first is we're going to put in observational controls for income and ask whether or not that can explain the differences in repayment that we observe. Pretty natural, given that we have the universe of income taxes, 1040s and W-2s, we can throw in the kitchen sink here. Okay? The second thing is we're going to use a causal strategy, very similar to the work that I did with Raj, looking at the causal role of your hometown exposure during childhood in shaping your repayment outcomes in adulthood, and then try to understand to what extent might that be mediated through the impact of hometown on your incomes in adulthood. Okay? And I'll come to that after walking through the first strategy. Okay, so let's do the first strategy. You're going to try to control for income. A lot of ways you could do this. What I'm going to show you here is just a regression of a non-repayment outcome on measures of race dummies and parent income rank. And I'm showing you those coefficients here in this bar chart. So the black-white difference is about 27 percentage points, conditional on parent income. The above versus below median income difference in parent income corresponds to about a 25 percentage point difference in the likelihood of experiencing a 90-day delinquency. All right, this is all unconditional on the credit score. This is just raw delinquency differences by race and by parent income. And now what we're going to do is put in controls for income. Okay? So the first income control I'm going to put in is just your base period income. That's the income at the time we're measuring the base starting period of these delinquency outcomes. And you can see that basically nothing changes. We can start to throw in a full vector of incomes between 2004 and 2020, which covers the period over which we're measuring the delinquency outcomes, and 12 years forward, just to try to see if we can get anything to go. So that doesn't really attenuate the coefficients very much, maybe a little bit on the Asian white gap there shown in green. We can also construct measures of savings. So it turns out we see your IRA savings. You can also have some administrative data that gets us home equity measures. We can throw in controls for your home equity. That does not take away these gaps. We can also turn to the SIP, which is a survey inside of census that we have linked at the individual level that gives you both total wealth and also measures of your liquid wealth. And we can control for measures of that. We can restrict to people that are in stable jobs, and we can even put in employer fixed effects. We can't remove a lot of these gaps that we're observing. These are really persisting, even conditional on measures of income, income volatility, your wealth, et cetera. You also see this across geography. So you can look at the repayment outcomes on the far left. This looks very similar to the credit score graphs I was showing you at the outset. That's what I showed you before. Here we can residualize off the component that was correlated with income. And you see that the patterns look quite similar. Places that have high likelihood of repayment are also places that have high likelihood of repayment conditional on income. And I'm going to return to that fact in a little bit. Okay, so it doesn't look like income is really driving a whole lot of the differences. In an observational sense, we can get a little motivation for what might be driving these patterns by going to that 10% subsample where we have the parent's credit score as well. And what you're seeing here in this upper right is that conditional on the parent's income, the kid's income, the parent's wealth, and the kid's wealth, if you go from the bottom to the top of the parent credit score distribution, it corresponds to a 44 percentage point difference in the likelihood that child in adulthood falls 90 days delinquent on an account. Okay? So suggestive that there's perhaps more than just the income streams that are driving these differences. But to try to get a little bit more deep into this, we're going to develop a causal strategy here And I'm going to do this at the cost of focusing solely on the hometown gap. So of the three gaps I talked about, race, parent income, and hometown, we're going to focus in on the hometown gap and try to understand to what extent is that driven by childhood inputs, and then to what extent is that mediated through the impact of childhood exposure on income. I will say some of this we're going to have to stay tuned. Like David, we're a little bit behind with the shutdown on what's getting through to disclosure here, but we're pretty excited about the patterns. Okay, so conceptually, how are we going to do this? The experiment I want you to have in mind is suppose we randomly assigned you to grow up in different counties of the United States. So for example, I actually grew up here in the Minneapolis area. About 64% of people do not fall delinquent on their stock of debt if you grew up in Minneapolis. You can contrast that with my poor co-author who grew up in Tampa, where about 40% of people actually do not fall delinquent. The experiment I want is to try to think about, is this because we grew differences in the ages of kids. That analysis, and what you see here is that if you look at kids who move before the parents are born, so the kids moved, the parents moved, right? But we know that they will eventually have that child. They pick up about 90% of the difference in the colors on that map. The later those parents move when during their kids' childhood, the less of the differences in the colors on that map do their kids pick up, all the way up to about age 23, after which they don't seem to pick up any more of that gap. The argument I want to make to you is that this slope reflects the causal effect of childhood exposure to those places, right? That every year a child spends growing up in a place with a bluer versus redder color, they themselves will be more likely to repay a loan. Now, what is the core concern that you should have in mind is that perhaps there's dynamic sorting of families. Maybe good parents, so quote unquote, go to good places disproportionately when their kids are young. We deal with this through a battery of tests in the paper and through other work that Raj and I have done. The simplest and quickest thing I can explain in under a minute is to put in family fixed effects and compare siblings of different ages. In other words, if you have two kids, a 2- and a 5-year-old, you come to Minneapolis, the difference in the repayment outcomes will actually be, the 2-year-old will pick up more of the Minneapolis effect than the 5-year-old, and actually in proportion to the age gap between those two siblings, all right? Okay, now that's on the repayment gap. We also have some work on the race and parent income gap that I'll talk about maybe if I get some time at the end. But just to sort of conclude here, let me try to put this into perspective with 4 graphs. In the upper right, we've got upward income mobility measured in tax data. So actually just throw away all the data I showed you here. This is the work that David was mentioning, looking at the average incomes of kids who grew up in different counties of the United States. You can see that's highly correlated with the repayment outcomes, correlated about 0.8. It's not perfect, but it's pretty highly correlated. And so you might have imagined that's just income causes repayment. But I already showed you if you control for income, it doesn't seem to take that away. Another way to see that is if you look at repayment conditional on income, you get the same map. And so what this is more consistent with is that across place, there are common factors that are causing both high outcomes in the labor market and better outcomes in the credit market. And that they're factors that seem to be correlated with childhood exposure. What might those be? Well, we have a discussion of this in the paper, but the strongest correlate that we can find is actually measures of social capital, in particular bridging social capital. This is the fraction of friends that you have from high-income families, very much related to what David was talking about, but here thinking about it as a notion of social capital. How many of your friends are from more affluent backgrounds? And you can see that varies across the United States and is actually the strongest correlate that we have, both of upward income mobility and repayment conditional on income. So that's the paper. Primary point I want to leave you with is that the credit constraints that we observe in adulthood, we think have their roots in childhood. Thanks.
Okay, so I guess I'm all mic'd up, so I don't have to. speak into the mic. So I first wanted to kind of thank the conference organizers for giving me the opportunity to serve as a discussant. This is a topic I'm super interested in, so I truly appreciate the chance to read the paper. I'll start out with just talking about the importance of this research. So it seems like every day I look at the internet or news, there's some other article talking about household debt. We live in a time now where it's more important than ever to understand how households interact with credit markets. And this paper actually tries to kind of add to our understanding of credit market access. So let me start. I mean, Nathan did a great job of explaining his paper, but let me start by just recapping a few things in terms of what the paper does. It assembles a large linked administrative data set. It examines patterns of credit access, like credit scores, credit utilization, alternative financial services, and it examines the role of characteristics and early life geography-based factors in shaping adult credit outcomes. This is a comprehensive paper. I don't think it's hit the 1,000-page mark, but it's up at 100. So this is quite a comprehensive paper. So there are a number of significant findings in this paper, but I'm just going to highlight a few of the main findings that I found particularly compelling. The first is really just documenting this large credit score gaps that emerge by age 25 and persist throughout adulthood. And I'm just pulling these approximates from Table 1 in the paper. You know, the black-white average gap is about 100 points. The bottom versus top income quintile average gap is over 100 points. And these are actually, the average gaps are smaller than when you look at the median gaps. They show and talk a lot about and add to our understanding of the distinction of different types of biases. They make a clear distinction of the calibration versus the balance issue bias. Nathan talked about the calibration issue, which is kind of controlling for the same credit score. Low parental income individuals and Black individuals are more likely to fall delinquent than otherwise similar peers, so similar by the same credit score. But what the paper also goes into is the balance bias, a balance issue, which is among borrowers who do not go into delinquency, low-income individuals and Black individuals still receive lower scores on average. So there are these two conflicting and contrasting types of bias that you find in the data that I think it's an important distinction and differentiation to make. A couple of the other main findings, they show that hometown effects do predict repayment beyond observables, and then they discuss, and Nathan didn't get a chance to talk about these several mechanisms for the higher delinquency rates of disadvantaged groups are explored. Just to be clear, I like the paper very much. I think it's a great paper. It's an important area for research. It has a set of really comprehensive findings that add to our understanding of this area, and it is extremely well executed. Some of the key contributions to the literature, I think, I just can't overlook the Herculean effort it was to construct this data set. The fact that you have a 1% population sample and it's supplemented with other census data sets is just super impressive. That it's linked with credit bureau data and IRS records is actually quite a contribution to the area of household finance. I think it's really important that they make clear the distinction between the types of biases, the calibration bias versus the balance bias. And I also think the paper kind of skillfully bridges mobility and credit market research. You saw several maps in his presentation, but I think those maps in terms of just facilitating our understanding of what's happening in the credit market space is really important. They map credit access, repayment, and scores by race, parental income and geography, and it really kind of allows us to trace credit access disparities to childhood environment and geography. And so this is just an example that was showed before. I found these graphs very powerful in terms of facilitating our understanding of being able to say, even within race and income group, we see these huge distinctions by geography, which I think has been an underexplored point in the household finance literature, at least. I will say, in terms of the other contributions of the paper, I think it has a lot of policy takeaways that I think are really important. Just really the fact that early life environment shapes adult financial resilience, I think, is important. That credit inequality is an intergenerational mobility issue, I think it's important. It gives a rationale for why regulators should assess predictiveness and equity jointly, and it also provides a framework that can inform kind of consumer finance generally and government fairness audits. Like I said, this is an impressive piece of research. I struggled to find some useful, productive comments, but I'll humbly offer some suggestions for the team of authors in this work. So first, in the area of data, kind of sample coverage and bias, they indicate in the paper that 10% of the sample lacks credit files. And so this could create potential selection bias. Is it the case that the lack of credit files are concentrated in kind of the low-income groups or the minority groups? If that's the case, actually that works against you, so you could be understating your results, but it would be worth kind of exploring and unpacking that issue. I would suggest consider comparing the individuals that you can match with the individuals that you can't match along some characteristics to see if there really are some systematic differences in the people that are being left out of the analysis. The next suggestion, the next comment I have is with respect to the calibration bias. The other issue is that the calibration bias actually may reflect some structural differences in income volatility or income shocks that differ by racial group, for example. And so trying to unpack and understand that a little better, I think, would be helpful. The authors do acknowledge in the paper that the analysis uses some really strong assumptions that don't necessarily hold in practice, but I do think those caveats are important to acknowledge. And then with the balance bias, that again could be due to historical data bias or omitted variables, and it would be important to kind of identify that a little bit more strongly in the paper. I think with regard to kind of the identification strategy and the causal claims, you know, within this kind of Chetty-Hendren place effects framework, it got me to thinking about how much of the variation is causal versus mechanical. And so I'm thinking about this in terms of kind of the first point is selection into credit markets may bias the place effects. And so the point is that the credit decision in terms of either access or type could be endogenous to local conditions, and that would be an issue to address. Also, kind of migration and sorting can complicate the identification strategy. Are the movers systematically different from the stayers? Are movers or stayers equally represented across the key demographic groups like low parental income or race? And so this might be an opportunity to explore further in the paper. I could offer a suggestion of maybe doing a movers only model or maybe origin, destination, fixed effects types of models to try to address potential concerns with the causal identification. Then I had just a few other kind of random thoughts about the paper. I was really curious as to whether the persistence of the gaps are due to the initial conditions or kind of the market amplifications. And so I was wondering if you could provide a little bit more information on that by perhaps considering estimating transition matrices across, how do people go, how many people go from subprime to prime or from thin to thick credit files. And so there's an opportunity to maybe unpack and get at that issue a little bit more. I think that would be interesting. I know the paper is really clear, one of the footnotes, that you use the Vanguard instead of FICO, because by using FICO, you limit the amount of people that actually have credit scores. I think it would be kind of cool to see if you could replicate your analysis with FICO, because it is the most commonly used score that most people know about. And then the last point that I'll make on this slide is I know that you mentioned when you control for immigration, the differences, the white Asian differences are mitigated a lot. But I think there might be an opportunity to explore some of those differences a little bit more, especially because Asian is a very big group and it's not homogeneous. And so trying to unpack and understand some of those differences. I mean, if you just look at the means or medians in the white Asian, there's it's like 60 points at the median difference. And so that might be an opportunity in paper, follow-up paper or something. And then the last couple of things that I'll mention is the cool thing about this paper is it really made me think about, it caused me to think about more questions. And so I'm not suggesting you make the paper any longer, but there are some opportunities for future research. Specifically now, fintech companies have their own types of credit scores or alternative credit scores. Do these other types of credit scores reduce or replicate the bias? Trying to understand which credit types drive the disparities the most. Is it auto loans, student loans, or credit cards? I think would be an interesting point to make. Would kind of race-blind models help or harm fairness issues? I think that's an opportunity to explore. And then another question that I had is, you focused on this one cohort, but I was wondering how stable are place effects across cohorts and time, right? So I will end with, just kind of my concluding remarks. I know I had a lot of suggestions, but I really want to emphasize the fact that I do think this is kind of path-breaking integration of kind of the credit mobility and credit and mobility research. It is a sharp, empirically rich, and policy-relevant piece of work, and I think for me, it's part of a new and developing research frontier that I think is really exciting, thinking about financial mobility economics. So, thank you.
So now we'll move on to questions. So what we'll do is first we'll just pull up a bunch of questions, everybody's questions, and then Nathan, you can respond to Vicky and answer the questions. Mic runners. Oh, and if you want to say your name, because there's people online as well.
Great. Kyle Herkenhoff, and yeah, great talk. Nathan, I got a few questions about income, and at least when we've kind of dug around in the LHD, the zeros mattered quite a bit, and I wanted to ask how you're handling the non-filers. And when you do the controls for lagged income, have you explored with flexible functions of the differences in lagged ranks to look at income shocks? And then there was a comment that you made about this reflecting purely supply side aspects of credit, this gap between the low and high score. And I mean, if you look at other indicators like the fraction that are banked, right? So to go in and open up a bank account, you see big differences across those two racial groups. It presumably reflects the demand side, and as well on fractions with different types of loans, the compositions of debt, just fraction with credit cards. I'd be curious to see what those look like in your sample.
Hi, Christina Ariano, Minneapolis Fed. Very interesting, Nathan, this work. I had a question about whether you've thought about a credit market channel for the persistence in the credit score. I mean, if you start with low credit scores and high interest rates and have to roll over debt at very high interest rates, it's really hard to climb that credit score, improve your credit score over time because of it. And so that could be, a rationale for some of these patterns. Certainly for sovereign debt and, partial default in sovereign debt, that's sort of one of the main causes. And the second thought I had on that is, again, thinking about the credit markets. I mean, banks in the United States lots of banks are regional banks, and so different policies of banks on how they deal with late payments and so forth, could potentially explain some of the regional patterns you find.
Great. Thanks, Jim McGee, Bank of Canada. Very nice talk. So I'm not sure if you had a chance to look at, are there year effects? Can you pick up some business cycle effects where you see different regions getting hit by income shocks, and is that correlated with some of the gaps that you see across racial outcomes?
Hi, Agustin Hurtado from University of Maryland. One question I have about the place effects is, have you considered exposure to financial institutions as a explanation to some of your findings? And the reason I ask this question is two ways. One is for traditional financial institutions, we know this macro trend of branch closings, right? And that those branch closings are heterogeneous depending on the geography. And the second is also exposure to alternative financial institutions like payday lenders, pawn shops, et cetera, might be important.
I'm going to add one question from online. So the question is there a way to look at the first instance of credit access for each ethnic group and see whether the nature of the initial debt has an effect on credit scores and future delinquencies?
Great.
Okay.
All right. Thank you. First off, thank you, Vicki, for that really wonderful discussion. Thanks for all the questions and comments. Okay, sure, I can wander up to the front so people can see me. Get the chair out. All right, so I tried to write down a lot of the great thoughts here. So let me just walk through a few. There's a couple things around sort of the geography, and should we think about the geography as perhaps reflecting kind of mechanical effects of like differences in kind of credit supply in different areas. And one thing I will just highlight, I want to plug the Keyes, Mahoney, and Yang paper that some in the room might be aware of that looks at movers across place during adulthood and actually shows you don't pick up any of the differences in repayment outcomes across place in adulthood, which I actually think speaks to several of the mechanisms that were raised in the questions, and I think reiterates that it's really a childhood exposure effect that seems to be operating, driving the geographic differences that you're looking at, and that these effects are quite persistent over time. These are not really affected by year effects, or like you were seeing very similar patterns if you plot 2008, 2020, and 2012 and 2016. They're quite similar, and some of those graphs are in the paper. I think the other question is sort of this chicken and the egg question. Obviously, if we extended more debt to people, they would be able to not fall delinquent on the existing stock. You would expect you'd be able to just keep borrowing, et cetera. The one piece of things that we have in the paper that I think speaks a little bit to this is sort of the kind of what goes on at very, very young ages in the paper and what happens with the calibration bias by age. And the thing we show is that at very young ages, actually, the credit score differences are not as large as what they are at later ages, yet the delinquency outcomes are pretty dramatically different. In other words, there is 3 to 4 times as much calibration bias at young ages, around 25, as there are at about age 30, 35. And so at least from this kind of perspective, from a Granger causality style perspective, it looks like what is happening first is the incidence of delinquencies, not on traditional forms of debt, but really on utility bills, the cable TV bills, the phone bills, that are then telling the market that you are predicted to not be perhaps a very good borrower. And then I think it's an open question on whether or not that's the right information structure we would like in the markets, but I think the reality is sort of conditional on exactly how we have set up the credit scoring system. This is really the kind of fundamental pattern that is going on. I think on the sampling selection, I think it takes some great points there. I was also really excited Vicki brought up some of the balance bias issues that I didn't have time to speak to and can hope folks can take a look at in the paper. The other thing I'll flag is in the appendix, we have a discussion of what is the first trade line that people get and how does that vary by race and class. And it is a little bit different. So Black individuals are more likely to first get a student loan as opposed to a credit card. But interestingly, that's changed over time. So now it's more likely to see student loans. Before, it was more likely to see credit cards. But actually, the equilibrium kind of differences at a given age in the credit scores has not changed much, which suggests that we're really looking at a structural, deeper kind of intergenerational problem in terms of credit access. So that's what I'll have here. But really, thank you very much for all the comments and the wonderful discussion.
Zoom at 11:35 Central Time, so have some time for discussion.
All right. Our next presenter is Richard Odali from New York Fed, and he's going to talk about the life cycle dynamics of wealth mobility.
All right, so thanks very much for having me. This is joint work with Rory McGee and Sergio Ancampo from the University of Western Ontario, and Gonzalo Paspalo from the ECB, and so some of us are at central banks, so there is a disclaimer. Okay, so our starting point is the fact that intergenerational, so what's sometimes known as social wealth mobility, is key as a context for the wide range of wealth inequality that we observe in most developed economies. It's key in the literature. It's also key in the public debate, as we've seen in the previous talk. At the same time, there are many different motives and vehicles for people's wealth accumulation. And so it's likely that as individuals accumulate wealth over their lifetime, their wealth rank is going to vary a lot. The question is, given all these different motives and vehicles for wealth accumulation, so that can go from precautionary savings to housing and retirement, the question is how much these ranks are going to vary over their lifetime. Who moves and what is behind these mobility patterns? So that's the question we are trying to answer in this paper. In this project, we try to flexibly add non-parametrically characterize lifetime wealth mobility, and we're going to be doing that using data from Norway. So it's very rich administrative data on wealth that covers the period 93 to 2017. So to be a bit more specific, we're going to be doing two main things in this project. The first one is we're going to study individuals over the lifetime as they transition through the wealth distribution. So we're going to study individuals' relative and absolute mobility, so within cohort wealth rank and wealth levels. But at the same time, there are as many of these trajectories as there are individuals in the data. And so key sort of methodological innovation we're going to bring to this data set is we're going to use clustering techniques to find typical trajectories through the wealth distribution. So we want to think what are the most typical paths that people are taking through the wealth distribution within their cohort as they age. And that's going to be made possible using these clustering techniques. In the second steps, once we retry these typical trajectories, we're going to think about what is driving them. So we're going to think about the role of heterogeneity in income, savings, and returns, and the role of lifetime choices and events, so most prominently portfolio composition. And then we're also going to ask, in the spirit of the intergenerational mobility literature, what are some of the kind of predetermined characteristics or characteristics that are given at labor market entry at age 30 that are going to basically put you on different wealth trajectories in terms of these main typical trajectories we retrieve with the clustering technique. So in terms of contribution, there is a very, very large literature. I'm not going to go through all these papers. I'm just going to mention one thing, which is in terms of the literature on wealth, a lot of the focus has been on the top wealth shares, right? So either in the cross-section or for the handful of papers that are actually looking at longitudinal data, that would be looking at people who make it to the top, within the top wealth shares, or people who are falling on the top wealth shares. What we're doing and what sets our paper apart from these studies is that instead we're looking at the entire wealth distribution, and we're going to show that there are some interesting mobility patterns, systematic mobility patterns, even below the top 5, 10%, 1% that has been the focus of the previous literature. Okay, so I'll just move straight to the data. So we're using Norwegian wealth data in this paper. So that's a very rich data set that has several advantages. So there's no top coding, and there's limited misreporting in this data because most of it is third-party reported. So think like your broker or your bank sending this information straight to the tax authorities. We're going to be focusing on wealth. So here, for what we're doing, we're not including public pensions in this data. And that just to make clear in terms of the exercise we're going to be doing, that we don't have transaction data, so we can't precisely distinguish between returns and savings. One thing we do in terms of this data is we do adjust for the tax value of real estate, and this is really important because we're looking at the entire distribution. So for most people, like the main asset in their portfolio is going to be their house. We focus on wealth at the individual level. So what's nice is it's basically the way the data comes to us. So we directly have a measure of wealth at the individual level, and so this way we don't have to take a stand on household formation and dissolution. We can just track individuals directly from labor market entry until late in life. And in addition, we can link to administrative recourse more broadly, so we have information about people's education, family, income, and so on. Once we impose this restriction, we're going to be focusing on Norwegian residents between 1993 and 2017. So we exclude people who immigrate and emigrate out of the country, and then we focus on the birth cohorts born between 1960 and 1965. So the reason we are doing this is there's nothing really specific about this cohort. It's given the time coverage of the data. These are the people we're going to be observing when they are about to enter a consolidated labor market entry in their 30s, and then we track them for most of their work life. Once we do that, we are left with about 300,000 individuals, a bit less, 280,000 after balancing, so it's still a very large data set. So if you were to compare and impose similar restrictions in the PSID, you would be left with about 1,500 individuals to give you a sense of magnitude. So it's very large. It's a large data set. What we do is kind of simple in terms of the main definition and the main objects of interest. So we compute the within cohort rank, simply ranking people's wealth at each point, at each age for each cohort separately, right? So it's just your rank within your cohort as you age. These taken together is going to give you a histories of ranks, and then you can track people, and you get these, in our case, these 25-dimensional vectors of ranks for each person that you track, year after year as they age. And that's the key object of interest. Basically, we're interested in the distribution of these trajectories of ranks for each individual in that specific cohort we're looking at. Just one thing I want to point is even for the population as a whole, it's not the case that these ranks don't matter, in the sense that even for most of the distribution, small changes in ranks do translate into reasonably large changes in wealth. So if you look at the median individual at age 40, if you go up 10 ranks, it's about $60,000 US dollars. Okay. So the first exercise we do to try and put things and think about this mobility in wealth, give some context, is we're basically going to compare the mobility in wealth to the mobility in income in this data. We first do this in a very simple way that's basically related to the first paper we saw today, which is we look at rank, measures of rank persistence, or measures of relative mobility. So the main one we're going to look at for now, we can focus on the rank persistence measure here. So that's basically, the same regression we discussed a bit earlier, where you regress a person's rank later in life, so on their initial rank. And if you take 1 minus this measure, you get 1 measure of mobility. So the exercise you can do is you can plot the intra-generational mobility. Is again comparing to your initial rank at age 30 in wealth and in income. If you do that, you get this first finding that's extremely robust, that actually mobility in wealth is much larger than the mobility in income. So here, if you just focus on the solid lines, so the blue one would be the one for wealth, the gray one would be the one for income, and you can see that mobility, the top one, you can see that there is much more mobility in wealth than mobility in income. This is an extremely robust finding. You can try different measures of relative mobility, Shorrock index. You can try measures of absolute mobility, and you basically always find something similar. So that's sort of the baseline finding, that it seems that for the cohort as a whole, there is quite a lot of mobility in wealth, which in some sense is a bit surprising because wealth is a stock, so you would expect it to move more slowly than income, right? And so the next question is how broad-based is this mobility, and what or who is driving those patterns? And that's where we're going to turn to this clustering exercise to try and distinguish these typical trajectories through the wealth distribution. So our goal, again, is to identify the most typical trajectories through the wealth distribution, and we're going to be doing that through one clustering algorithm. So the one we're using, the baseline one we're using in the paper is called agglomerative hierarchical clustering. The idea is sort of simple. You start with as many groups as there are individual, and you sort of recursively group the people who are the most similar in terms of their wealth rank trajectories using some distance metric, right? It turns out that this algorithm has some nice property, but one of the nice property is as the name would suggest, it's hierarchical. So you can always, you can always sort of open up one of the group and see a bit what's going on in there, basically. In the baseline analysis, so it's both, for exposition, we're going to use 4 group, G is equal to 4. And then we go to many robustness in the paper of that. It turns out that G is equal to 4 explain about 50% of the variation in ranks in the data. Okay, so that's the sort of main empirical finding. So again, the exercise is you've got all these vectors of ranks, histories of rank for each individual. You're being completely agnostic. You tell the algorithm, create 4 groups, and that's what you get. So you get first 1 group, that's always at the top. That's about 20% of the cohort. You get, so we're going to call them, wealthy or high ranked. Then there's a group that's always at the bottom, that will be poor or low ranked. And then you got 1 group of climbers who are basically climbing steadily through the wealth distribution, and 1 group of the one we call sliders, who are the ones who are basically drifting down in the wealth distribution, and they sort of cross around age 45. Okay, so that's sort of the main the main empirical pattern that you get from doing this exercise. And it turns out, because that's sort of an important result for the paper, that it's extremely robust to using alternative clustering algorithms. So another of those algorithms is, K-means, so you can find a similar pattern. You can use, different measures. So if you don't like ranks, you can use other transformations of wealth, and you find something similar. One thing that, I think is quite convincing in terms of, seeing that this is not a mechanical pattern is that if you do the same exercise, exactly the same exercise with the income, then you would get 4 horizontal lines on top of each other, and no crossing pattern, right? So again, speaking to the fact that income seems to be more persistent than wealth in ranks. And then, just to be clear, there's still a lot of variation within this cluster, so you can, potentially, this is really segmented mobility, and people are going to be basically moving within their segments, but that's the sort of 4 main groups that you get. And you could explore a bit more the heterogeneity using the subclusters that are in each group, because again, this algorithm has got this hierarchical structure. If you now, take you take these 4 groups and you just plot the average wealth in each group, the pattern is in some way even more striking. So again, this is the same 4 groups. All I'm doing is just taking the average wealth in each group, right? And so you can see that the group at the top and the climbers, they are actually, they have very strong growth in wealth throughout their life. And the group of sliders is actually sort of, increasing, but at a much lower rate, and even some sort of stagnating after age 45. One thing that's worth pointing out is that the group at the bottom, which is about like 40% of the population, they would have on average almost zero wealth until net wealth until like say the late 40s, early 50s, right? That's the gray line here at the bottom. Now, if I go back to my initial wealth mobility plot, so the dashed line would be the average across the 4 groups I showed initially, and then if you do that, group by group, you can see that the mobility is actually driven by these 2 middle groups that we find, the groups that's sliding through the wealth distribution and the group that's increasing through the wealth distribution. So the blue and green line, and the other 2 groups have much more persistent rank, as the picture would suggest. So the next question is then, in a more conceptual framework, how should I think about this mobility? Is that something you would expect? So what we're doing is basically trying to relate it to canonical models of wealth accumulation. So we have 2 main exercises. First, we look at the standard buffer stock model of saving. And the key findings of that type of basic life cycle model with only skill differences is that skill differences alone, so income differences alone, wouldn't be enough to generate this crossing pattern. So you can actually show analytically in this class of model there is a mapping from wealth accumulation to income profile. So if you would get 4 lines on top of each other in this basic class of model. That's building on a result by a paper by Ludwig Straub. Then you can go a bit further and think about statistical models of wealth more generally, and we see those models as an approximation for a broader class of life cycle models. So what we do is basically we vary the parameters in the 2-equation model. So where you have a wealth accumulation equation, so that's the one on the bottom left corner, and the process for log income here. And you can vary the parameters in this 2-equation model, and basically you can simulate from them for reasonable values taken from the literature and try and think, what does it imply for my crossing pattern, and do I get the same type of standard pattern as you would see. So what you find is so if you look at the left plot first, we confirm the finding, the analytical finding, that if you only have differences in income, you're going to get 4 straight lines on top of each other again, right? That's just basically checking, statistically that the result holds from the theoretical result holds. And then to get the crossing patterns, what you find is that you actually have to sort of cook up the thing quite a bit, is that in the sense that you need return heterogeneity, and you need on top of that to have to enforce a negative correlation between initial wealth and return. So it's almost like writing down the result, but you need to sort of really force it to get this type of crossing patterns, at least in this basic statistical model. So the sort of takeaway is that it looks like you need some sort of returns or saving heterogeneity on top of income heterogeneity if you are to generate this type of mobility patterns over the life cycle. One challenge and one limitation I do want to point out is that in terms of the marginal distribution of wealth, so here I just showed the rank, but the marginal distribution of wealth that you get out of these models and out of let's say standard life cycle models is really off by a lot. So in the sense that you're not generating enough dispersion in wealth, so you want to take these results with a grain of salt, but at least in terms of the overall pattern, that's what you get. It seems like you need some sort of return heterogeneity to get anywhere near this crossing pattern. I'm going to briefly mention something about the drivers of wealth accumulation. So again, the data is very rich, so you can link to a wide range of lifetime outcomes. I'm going to just focus on 2 of them, which are portfolio composition and income. So if you first look at portfolio composition, here I'm showing you portfolio composition in terms of property, private businesses, stock bonds, and other wealth for the 4 groups at different ages. But basically the takeaway you can see from here is for the majority of these people, this is mostly property wealth, right? There's not very little you can see that at the top there is a bit of private wealth, but for the majority of these guys, it's going to be just housing. This is not so surprising because, again, we're looking at the entire distribution, so you sort of would expect most people's wealth to be mostly in housing. But in terms of the result, the previous result, that you need differences in returns to generate these crossing pattern, this mobility in wealth over people's life cycle, it means that these differences in returns, they are really within asset categories, right? Because like in terms of portfolio composition, these guys, they look very similar. And then in terms of income, so this again is average income over people's lifetime for the four main groups. You can see again that, it's sort of what you would expect. The climbers, they sort of have larger incomes than the sliders, and they sort of, catching up in that sense. But what's maybe not so apparent from the picture is actually especially in the Norwegian context, the income distribution is very compressed. So these differences here, they're not nearly enough to sort of generate the patterns that you find in the data in terms of wealth dispersion. Again, that's not like very obvious from the picture, but if you were to do some back of the envelope calculation, you would find that you're way, way off if you just input, this type of income profiles into some sort of budget constraint and try to derive wealth. Okay, so in the final 2 minutes I've got, I'm just going to say something about the determinants of this trajectory. So now the exercise is, I want to think of characteristics that are given at age 30 at labor market entry in the spirit of the intergenerational mobility literature, and I want to think which characteristics are basically going to put you on the different wealth trajectories using these four groups. I'm doing something very simple here. I'm estimating a simple logit model where on the right-hand side, I've got, again, a bunch of these characteristics that have been proven good predictors of future lifetime outcomes. So I've got indicators for parental wealth in 93, so at the start of the period. And I've got also a bunch of education and subject domains for the type of education, the maximum education level you got. If you do that, you get two main findings. So the first one is that parental wealth is going to predict within the top group or the bottom group. So basically tell the always wealthy and the people at the bottom apart. So that's what's on on this plot here. I'm plotting the average partial effect of your parental wealth ventiles, right? And you see that as you go up, as you go up, you can see that starting with parents in the top, say, 30 or 20% of the wealth distribution, you're really much more likely to be in the groups that are always at the top, or conversely, much less likely to be in the group that's always at the bottom, okay? In terms of education, instead of telling, it's more telling apart the people who are rising and falling through the wealth distribution. So here I'm plotting, same thing, the average partial effect for my logit, but looking at highest level of education, so high school, technical education, undergraduate and postgraduate. And you can see that the people through the who got the postgraduate qualification or undergraduate qualification, they're more likely to be in this group that's sort of rising through the wealth distribution. And conversely for the people sliding through the wealth distribution. So again, these are important differences, but you have to remember that if you believe these simulations, because income is so compressed in Norway, these channels, they don't operate solely through income, they have to operate through something else, right? Either returns or savings. So I'll just summarize and conclude. So again, the contribution is the technical contribution is we flexibly characterize these distribution of lifetime wealth mobility using this tool from clustering, and we've got several key takeaways. So the first one is that we find evidence of substantial changes in wealth rank over a quarter centuries, and these are larger than the ones you would find for income. Using the the clustering techniques, we find that mobility is primarily driven by this selected group in the middle of the distribution, so the ones that are called risers and sliders. And then the simulations, they point to differences in saving behavior, so be they returns or savings rate, as differences that matter beyond income to explain these mobility, these wealth mobility patterns. And finally, that was the last slide. Parental background and education, they predict very distinct wealth trajectories, with parental background predicting more the groups that's always at the top of the wealth distribution, and education predicting more people rising through the wealth distribution. So that's what I have. Thanks very much.
Thank you, Richard. Our discussant is Fabrizio Peri from Minneapolis Fed.
Excellent. Thanks a lot for inviting me here to discuss it. So it's a fun paper. So let me just tell you outline what I'm going to do. I'm going to briefly summarize the paper. And then I'm going to go to US and try to assess whether Norway is different from US. And in some dimension, Norway is very similar. Some dimension, I argue, is going to be pretty different. And then I'm going to try to go and see what can learn about, mostly for US, from models of wealth accumulation. This is heterogeneous agents model, which is now very important, what you can learn from this data. Okay, so a summary of the paper. So these guys, they have this cohort 60, 64. That's very disappointing. We have a Norwegian colleague, Kjetil, is not there, doesn't make it a cohort. Well, otherwise, he would be there, because you could look up his name and it's wealth. So all the Norwegians are there, born in 64, and they follow from 93 to 2007, so from 30 to 55. And they have lots of data, income, wealth, even parental background. Now, the key thing, as we all know, wealth is very unequally distributed. A lot of people have zero or negative, and some people have lots, so we know that. Now, this guy said, yeah, okay, we know that, but how about, do people move around, or do you have, a story like that? People at the top are always at the top, people at the bottom are always at the bottom. And they say, no, there is a lot of mobility. There's a lot of reshuffling within distribution. And they characterize, they use this kind of like more advanced technique to show that there's 4 groups. You can summarize all this mobility in 4 groups. The top dwellers, the guys stay on the top, they're always on the top, like the rich and famous, that they live in their own class. The bottom dwellers, the people live in the slums, they never got out, no wealth. But then there's these 2 groups that are more interesting. The climbers, they start very low, but they get to the very top, almost. And the sliders, which just start at the top when they're young, but then they go down. And so then they go like, who are these types? They try to get a little bit, using the data to get a sense of what are these groups, and then they draw some lessons for heterogeneous agents model. So let me go quickly through that. I mean, Richard did a good job, but so this is the key slide, I think, the group. Black is the, so now first notice, this is not ranked, this is actual wealth. So wealth actually grows for everybody. Everybody through the life cycle grow their wealth. People get rich, they accumulate. But the key thing, they do at different speeds, so the ranking change. So the black lines are the top. So when they're young, they don't have a lot of wealth. They have 200,000. So at age 30, even the rich don't have a lot of wealth. But they start at the top and they grow fast, and they grow about 8%. So it's pretty robust wealth growth all throughout. So those are the guys that stay on the top, the 20% of that. Now, go at the bottom, there is the gray line, the bottom dwellers. They start at the bottom of the wealth distribution, and the bottom is 0. When you're 30, your bottom is no wealth, but they basically stay there forever. So by age 45, still they have no wealth. They maybe don't have a house, or they have a house with a big mortgage, and then at some point they start accumulating toward the end of life cycle, but at this point it's too late, so they're down. Now, the other 2 groups are interesting. The blue line is the climbers. They start at the bottom, but by age 40, they have accumulated some wealth and then take off. And then now they grow at the same rate of the other guys, about 8, even faster, 10%. And the sliders, on the other hand, these guys who actually, they're not at the top, but already by age 30, they have some significant wealth, $100,000. So I don't know very many people that by age 30 have that amount of wealth. But these guys, despite having this wealth, maybe they have a house or something, they fail to take off. and they kind of grow at 2%, and they kind of like, you know, by the end, they sit down. So roughly, just to get a sense, you can even oversimplify these things. There are two groups, the growers and non-growers. The growers are the top and the climbers. The non-growers are the sliders and the bottom. So there are really two groups. So that's kind of heterogeneity that they show. And of course, it results in pretty significant mobility because, you know, if you have a group that grows at 8% per year and a group that grows at 2% per year, of course there's going to be mobility. These guys, the blue line, are going to overtake the green. So that's where the wealth mobility comes from. Now, it's interesting. They're trying to assess a little bit who are these groups. I want to point to a couple of results. The first is the portfolio composition that Richard showed. Look at the blue lines, overtakes. Most of the wealth is in real estate. This is true almost everywhere. So most of the wealth people have is real estate. So actually, looking what the blue lines drew over time is really important to understand the experience in the wealth. And look at, for example, for most groups, the blue lines get bigger by age. What it means, really, they buy a house and the house appreciated. And that drives a lot of their wealth. The only group for which doesn't do it is sliders. The sliders, the blue line are, let's see if this works. They're like, no, it doesn't work. The blue lines are kind of very similar. So I think that one big thing that happened with the sliders is maybe they start with a small business, they don't have many assets, but mostly they don't experience real estate appreciation. So they're stuck because maybe, you know, they didn't buy the right house. And, you know, the people on the top, what do we see? They have a larger red. So they have, probably they start with a business. They have already a business, and you know, that's why they're very rich at the beginning of their life, and the business as well, and they keep growing. So that's one thing. And so that's, you can see, if you look at the second panel, the parental wealth rank, if you come, say, at the top 100, if you come from a very rich family, you're very likely to be high ranked. So basically, the story is that you have a rich family, have a business, you start at 30 with the business well, you're good. If on the other hand, you don't, and you're not very likely to be one of the bottom guys, because if you start with the wealth of a business, you're not likely to stay poor forever. Finally, education seems to be connected to the climber. So that if you have a PhD or postgrad, you're more likely to be a climber. Now, one thing I was thinking of that, I thought maybe the rural-urban is important. Because, you know, basically, if you have a lot of education, well, what you want to do, you're not going to work in a farm, you're going to go to Oslo. And if you stay in Oslo, home prices in Oslo are going to go faster than home prices in the countryside. So maybe I was thinking, I don't know if they have data, but maybe the location, where you're going to live and end up living, is important for this trajectory. So that's one question I had for them. Okay, implication for macro models. These guys, do I have timing? Oh, okay, perfect. They say there are two models out there. One is what we study a lot in graduate school, is the Iagari models. Basically, your wealth grows at the same rate, the interest rate for everybody, but you have some income shock, and these income shocks are persistent. The other one is like the more modern models. This is Ben Habib and Bizine have a JEL survey. Basically, your wealth grows, but the rate of growth of your wealth is heterogeneous. Some people have very high return on wealth, and some people have very crappy returns on wealth. And the income is the same. They say, look, if you have that model, those four groups, and we apply the algorithm, we're going to get these four groups. There's no crossing, no mobility in wealth. Why? Because in this model, mobility in wealth is the mobility in income realization. Since the process is sort of similar, it's persistent, so you're going to have some discrepancy, but not enough. So lifetime income not going to generate enough changes in wealth to get these groups, this overtaking. But if you have differences in the rate of return, then if I happen to draw a very high rate of return on wealth, my wealth is going to go way up. If I happen to have a very low rate of return, wealth is going to go down. So I'm going to have like these four groups. Because the black line is the guys who start at the top and happen to have a very good rate of return. The climbers are the guys who start at the bottom but have a high rate of returns, and so on. So you can get exactly these crossings. So they say, okay, we see this pattern. That's evidence in favor of this model. Okay. Now, I want to say, okay, very nice, Norway, but it's a few people, few countrymen up there in the northern Europe. How about the US, bigger country, more different? Can you do the same exercise? Well, having wealth data, you need a panel of wealth data. It's very hard to get. There's tax data, but tax data doesn't really have good dimension of wealth. There's SCF, is a very good survey, but doesn't have a panel. So at the end, the only thing you can do is PSID. Say, well, PSID is not great. Yeah, it's not great, but so we've done some work with Jonathan and Gianluca and Lishan, looking at how PSID compares with other sources of wealth. And the picture on the left shows this is just the average level of wealth. Now, it doesn't fully capture the level of wealth we see in flow of funds on SCF. The PSID is the yellow line, but it's pretty close. And in terms of wealth inequality, so this is just a share of top 10%, is also not that far from SCF. Of course, there is attrition, small sample, a lot of people going out, and we probably missed the very top. But as Richard was saying, this is not a paper about the very top. It's a paper about the whole wealth distribution. So I thought, let's do it. Let's go to the PSID. So wealth inequality in the PSID, nothing particularly surprising here. But here I did the same thing as I did. So I selected the cohort of the people, and now this I like because actually I'm the cohort. Well, I'm not in the US, but I mean, I can relate myself to that cohort. So the cohort of 65, 74 now have 10 years because so they have 5 years, they have a lot of data. Now I picked 10 years. I follow all these guys born in those years. In the PSID, I have about 2,200 people. The people who are there for all the years from 98 to 2002, 708. So there's about one-third, no, more than one-third of people so one-third of people I lose. Sorry, two-thirds I lose, one-third they stay. Of course, the attrition might not be random, but anyway. And this is household level, this is not personal level. So what you can see, you can very clearly see the Great Recession, the housing bubble and boom. So wealth goes up, then it stagnates for a while, then picks up again. So the mean and median, and you see P90, P95. So very, very unequal. So there's some people who have 0. So the P20, for example, is 0. So this is age 55, 20% of households have no wealth by age 55. So it's pretty dramatic. We all know that. It's not surprising. While on the other hand, P95, $2 million. So they get to age 55, $2 million. So sometimes people are surprised. Say, oh, PSID doesn't have the rich people. There are some people who have decent wealth in PSID. So it's not that they miss. So that's the distribution. One thing I want to say, that's maybe surprising. This distribution does not fan out over the life cycle. So if you compute any measure of wealth inequality over the life cycle, actually it's very high at the beginning. Because at the beginning, you have tons of people, so Gini, you have tons of people with 0, and some people have wealth, so wealth inequality is extremely high at the young people, and then goes down and it flattens out. So basically, of course, as some measure it fans out because you have people at 0, so the range goes up. But all the traditional measure of wealth inequality actually stabilize as the wealth grows. Okay. Okay. Yes. Okay, now I did something super simple, and when I saw it, I didn't believe the result. So I say, I don't have this machine learning things. I'm going to do just 4 groups in a very simple way. You start below the median, you stay below the median, you're stayers. You start at the top, stay at the top, you're top. And if you move from below to top, you are those groups. Here the exercise I got. Let me actually go to the next. That's what I got on the Norwegian data. That's what I got on PSID. It's pretty crazy how similar it is. Even the level, the level here is like, this is in dollars, constant dollars. So the top, they grow real fast. So of course, PSID is much more noisy. I have only 700 people. They have several 100,000, but it's very similar. So in particular, you see that the two groups, the guys at the top and the climbers, they all grow at the same rate, pretty fast. The people at the bottom stay down and never move, and the sliders have a little bit and then go down. So in terms of wealth, of course the groups are different, but it seems it's remarkably similar. Now there's something though which is not that similar, is the income. Now I got those groups and I look at their income. What research showed that the income in Norway was pretty similar across the groups. If I look at the income in the US, it's actually pretty different. look at, for example, on the income of the climbers, the gray line, and the income of the sliders. Very different. The climbers go from 50,000 to over 150,000. So it's like they triple their income over the life cycle. The sliders, no income growth whatsoever. So that tells you that, Richard said you need different returns of wealth. Here I'm saying, well, income already does something. So these groups have, the reason why they have different wealth trajectories is because they have different income trajectories, at least in the US. So Fatih, I don't know if Fatih is here, but over here has this very nice paper called HIP, Heterogeneous Income Profile. So I say, let's take a slightly different model than the Ayagari, in which we put people have different income profiles. So this is what I do. So I'm taking this same model of wealth accumulation, wealth tomorrow is equal wealth today. But now I say returns of wealth is the same for everybody. But now I have income has different growth. And if you happen to have fast income growth, you have these GIs is fast. And saving is also different. Because there's a very large literature show that the rich people save more. Simple thing is retirement. If you're very poor, you're going to get Social Security. When you're old, you need to save. If you're really rich, you want to keep the same standard of living, you save more. So there's different saving rates. So I'm gonna. These are just this calibration I did last night, so it's not a particular. But anyway, you say I'm going to assume that rich they save 15%. Because we saw that the people that grow fast, they have a higher level of income. The poor, they have low income, say 1%, 3% interest rate. And I'm just going to take initial wealth and feed the income I see in the data. That's it. And look what you got. It's pretty good for last night. I didn't. So and again, the key thing here, the interest rate is the same for everybody. So no heterogeneity in rate of returns, just income and difference in saving rates. So the climbers and the top dwellers, they are richer, they have experienced faster income growth, and they save more. But 15%, 1% is not, I've looked at some data. PSAD actually can measure saving rate, and you don't see that many very differences. Okay, so conclusion, this is, I really enjoyed the paper. There's great data and great data work. I think it's a clear contribution understanding the drivers of wealth dynamics across the distribution. And the one thing I really like, people say always love the paper. One thing I like about this paper is that it has all the tax contribution in the appendix, several appendix. Read the tax, it's all about the economics. Very, very nice to read. The one thing is not so clear, and maybe which Norway and US differ, maybe for US, return differential is, and again, we're talking about the distribution. Maybe the very top is different, but for the whole distribution, maybe you don't need very many differential returns, just need different income experiences.
Thank you, Fabrizio, and thank you, Richard, for the presentation. Time for questions from the audience. Marco?
So one thing that is...
If you could introduce yourself, sorry.
Marco Bassetto from the Minneapolis Fed. One thing that is tempting after seeing both sets of results is to interpret this as differences in patience across people. I know it's kind of... I frown when people put things into preferences, but there seems to be something that is worth thinking. It's connected also to the fact that these climbers seem to be associated with going for advanced degrees in Norway, so there seems to be a pattern of many things that indicate greater patience on their part, and that might be one explanation for difference in savings.
Jonathan?
I'm Jonathan Heathcote at Minneapolis Fed. Thanks. And Fabrizio made the same point, but I'm just repeating what he said, that seems like housing is the biggest component of wealth. And you kind of suspect that in Norway there are pretty differential house price dynamics for Oslo versus the rest of the country. I think there's been much faster price growth there. So I'm just curious, I think you said you'd done it, but how many of the growing group, for example, are they disproportionately people living in Oslo? I don't know if you know the answer to that. Thanks.
Hi, Jorge Herrera from the University of Minnesota. I want to understand the data. Do you have some notion of the people that go out of Norway and then come back in a way, because like this, yeah, like if you come to the US, like Kjetil Storeslet, and you come here, you make a lot of money, you come back, and then you buy the right house, right? And therefore your wealth explodes, right? Like, do you have some notion of people that go out of Norway, or they are all stayers in Norway? Thank you.
Okay. Because you're using Norwegian data, I don't feel so ashamed to ask for this, but do you have any sense of the parents' income of the people whose wealth you're observing? And the reason I ask is that Emily Nix has a paper with Finnish data where the consequences of job loss on wages are much less severe for job losers with higher income parents themselves. And so I wondered if you were seeing some wealth dynamics where people were protected from shocks because of family background and therefore made it into one of your categories or the other.
Any other questions? All right. Richard, why don't you come up to stage and answer the questions?
Questions? Thanks. So several things. So in terms of income first, I think, potentially, at least we're very confident in the income finding. So in Norway, you can try a lot of different exercises, and it's pretty clear that the differences in income are not enough to drive the differences in wealth we observe. Is that a feature of Norway because the income distribution is so compressed? But at the same time, you do see that the wealth distribution is, very unequal still, not as unequal as in the US, if you were to look at top wealth share, but very comparable to the rest of Europe, for example. So you get very similar top wealth shares. So in that sense, again, it seems that you need something else than income. And here in the simulations, we push returns a bit more. One limitation of our data, and that's really a theme that's going through a lot of the question, is that we can't really distinguish between savings and returns properly because we don't have transaction data, right? So all I see in the data every year, I see your stock of wealth from one year to the next. And I don't know if you saved a lot that year or if you had a lot of returns that year. So we left a bit in between on that front, and we can't really give a definitive answer. That's going to be the same for housing prices. Again, the same answer applies to that in the sense that we don't observe transactions exactly. So we're not going to be able to tell exactly. We see the portfolio increase and we see that housing wealth is increasing, but we don't know if people are changing house or moving. We do know their location, and my recollection is that the climbers are more, maybe not living in Oslo, but at least they're more urban. So, living in the larger cities in Norway, which are all pretty small. But that's sort of my recollection off the top of my head, so that would go in the direction you suggest. Yeah. Patience. So patience, yes, same answer. Again, one of the tests would be, ideally, if you could see returns and savings separately, you could make a bit more progress on that. Again, so sort of my intuition would be that actually the people who have higher return, they also have more patience, and that the two things would move together, but I can't really show that to you in the data. You can explain the data with higher savings rate or higher returns, and the two are sort of interchangeable, and you can't really conclude just based on that. About mobility and migration, so what we do, everything we showed here was for the balanced sample, so that's people who are always in Norway or always popping up in the tax data for the 25 years. So that would abstract from the people moving in and out. But it seems that, at least in Norway, again, like because, very affluent country, there is a bit less of this migration, at least in that cohort that you would expect. So I think, we started with 300,000 people in the cohort, and then we go down to like 280,000. So that was, that's fairly small magnitude of people actually that would skip at least a year in the data. And again, I think that's probably a feature of well, first it's like consolidated labor market entry. So we start at 30. So say if you study abroad for a while, like then you have come back by then, and then probably fairly affluent countries, so a bit less of these work migration, at least for that cohort. And then parents' income. So we do observe it. We have. Actually, we do something for wealth, right? We show some of these results for wealth, where you see that people with wealthier parents, they tend to be the people who are always at the top. For parents' income, we have it. We haven't really explored it, so yeah, that's what I can say. Any other questions?
Right. Thank you.
Thank you.
Thanks, everyone.
For lunch. So we'll return at 1:45 Central Time. We will resume the research program. Thanks.
So, hi, thank you for accepting this paper in the program. Ironically, Eric presented this 1 year ago when we didn't have a question, we didn't have nothing at that moment. So this is showing work with Hassan, Andres, the good Andres, and Eric. And basically, we want to start thinking how the labor market could respond to inflation. So, following many years of low and stable inflation, during 2021, we have a surge in inflation. Again, you have to understand that it was in the context of expansionary fiscal and monetary policy, and low unemployment and high vacancy to unemployment ratio. So here in this graph, we can see, not this. So here in the x-axis, we can see time. In the y-axis, we can see market tightness, vacancy to unemployment ratio. And we're seeing that during this period, there was an explosion of vacancies or unemployment. What was the main idea when economists saw this? We're living in a hot labor market. There are too many firms chasing too few workers. And again, whenever the demand of some goods go up, the price goes up, here will be real wages, and this will increase inflation. And here you have the phrase of Powell sustaining this idea. What is the main problem of this idea is when we see real wages go down. Here in this graph, in the x-axis, you have time. In the y-axis, you have both inflation and real wages. Again, now, in some sense, what we would like to start thinking is a theory in order to explain both market tightness together with real wages. And the main idea is super simple. And I remember one time I was at the gym saying this to a person. He said, of course, this is trivial. Basically, we want to start thinking this idea that if you have an inflation surge with sticky wages, it will decrease real wages, and this will trigger more on-the-job search in order to recover wages. What this is a simple idea, developing preference, technology, and market friction to justify this is not so trivial, and this is what we want to do here. Okay, so what are we going to do? We're going to develop a framework with search and matching friction, frictional labor market, with two key frictions. Friction number one, sticky wages. Friction number two, two-side lack of commitment. In our model, we're going to have endogenous flows. We're going to have key quits, layoff, when to renegotiate, and when to search on the job. And these are going to be all decisions of both workers and firm. The firm will choose when to quit, when to renegotiate, so on. And on top of that, we're going to have worker heterogeneity. Different workers according to income distribution are going to have different labor market outcomes. Okay, what we're going to show that in this environment, higher labor market tightness can come from an isolated increase in inflation. And the mental experiment that we want to start thinking is the following. Imagine a world where preference, technology, and other real stuff stay constant, and one day we wake up and the price in the supermarket went up. What would happen with the labor market? Okay, because we assume infrequent wage adjustment, nominal wages stay constant, inflation went up, so real wages go down. If you start thinking the fact that real wages go down is not a problem per se, and this goes back to Barrow 77. Suppose that I'm a worker, Ellen is the firm, and my wage goes down. What Ellen can always give me is a contract saying, you know what? I know your wage is super low, but do not worry. In the next opportunity that we're going to adjust wages, I'm going to compensate with higher wage in such a way that the present discounted value of wages doesn't change. In our model, again, we're not going to have this type of environment. Why? Because we have lack of commitment. I'm Argentinian. I will never trust another person. It's just that. Okay, what we're going to find is, okay, now, following the decrease of inflation, one of the ways workers can recover their salaries is by moving across jobs. We're going to find that inflation reduces workers' welfare by around 1K around 1K. And again, we designed this model to explain this episode, but the key is, are we talking about like one single episode, or are we thinking about empirical regularities? And for that reason, what we're going to go and check that in the past, whenever we see a spike in inflation, we see increase in the vacancy to unemployment ratio. And finally, not today, we're going to show that different shocks in our model is not going to be consistent to match both the job finding rate and real wages. Okay, so by the way, I know this is like no seminar question, but if you want to do questions, I'm super happy. I talk a lot with myself, so. Okay, what is the main idea is now we want to describe what are the labor flows during this episode from 2021 to 2024. And why we took 2021 is basically the first quarter, or in the second quarter of 21, inflation passed 4%. What do we see in the data? First, layoff went down. And the thing that, again, at least I find puzzling is when you take pre-COVID and post-COVID or post-inflation surge, we see a small change in the job finding rate. This is the EU rate, the second graph. And what this implies is most of unemployment dynamics were largely driven by separations and not job finding. The last thing that we see here is the job-to-job rate, and we see that there was a big increase during this inflation surge from 2.3 to 2.4. Again, in our study, we're thinking that one of the ways workers recover wages is basically by moving across jobs. What we should see that it pays off to move. That's the whole idea, if we think are correct. So here, in the left graph, we have the annual growth rate of job stayers and job changes. And what you can see, that during this period, job changes make around 6% growth rate annually, and the guys that move across jobs where the job changes were to 15%. That gap went, again, it's always around 3%, and during this period it went to almost 8%. What this is saying is it really pays off to start doing more on the job search. Moreover, in our model, we're going to have heterogeneity, so we can always speak about different labor market outcomes across different workers. So here we're going to plot real wages across the quantiles of the income distribution. The left graph, Q1, Q2, up to Q4. What is the thing that we saw in the data is the recovery was much faster at the bottom of the income distribution. Technology breakdown. No, now technology works. Okay, what do we learn until now? With higher inflation, we have higher job-to-job transitions, and nevertheless, constant job finding rate. Real wages of the guys that are moving tend to increase more than job stayers. Again, and there is some heterogeneity in real wage dynamics across the income distribution. And the key is vacancies shoot up, having almost constant unemployment. Remember that at the end of 2021, unemployment was around like 4 point something. It was already down. Our hypothesis, or the thing that we want to try to do is, okay, we want to develop a new theory that hopefully can explain it like a new social problem, and our model with self frictions, nominal wage stickiness, and two-sided of commitment can go and respond, basically replicate this. And we want to do it like Prescott used to do it, like we're going to have one, I don't want to say shock, one something exogenous, that is inflation, okay? Okay, what is the main idea of the model? We're going to have such a matching frictions in the labor market with sticky wages, two-sided of commitment, and now I'm a worker, I'm going to meet a firm, and we're going to start playing a non-zero-sum game within us. And the choice set is always when to quit, when to lay off, when to renegotiate. You can see that it's basically the stopping time. Again, we're going to have endogenous flows, quits, layoffs, job-to-job transitions. We're going to have heterogeneous productivity, cost of hiring, and home production, and homogeneous firms. And again, think this as a partial equilibrium model. We're not explaining what causes inflation. We want to understand how inflation affects the labor market. Okay, so now I'm going to start describing the economic environment. And the main idea is every time you see a parameter, I'm going to give you the strategy for parameterization, okay? So time is continuous and indexed by t. We're going to have a unit measure of heterogeneous workers that direct in direct search. They're going to die to some probability. We're going to match this parameter to match some quantile of the years of experience in the labor market. The worker can be employed or unemployed. During employed, that is the production technology. That is going to be A, that is aggregate, and C, that is going to be idiosyncratic productivity shocks that stick to the worker. I learned how to write the Bellman equation, so my productivity now is higher. So the unemployment worker is going to have B times C of phi B home production. And basically, we're going to calibrate phi B in such less than 1. And what is the main idea? When phi B is less than 1, the surplus increases with productivity. Therefore, job separations are going to be lower for high-income people. And what is the counterpart of having higher surplus for high income? Is the job finding rate is going to be higher. So how we overturn this? We're going to have homogeneous firm to post vacancies with this cost. And the main idea is you want to hire a doctor, the hiring cost is going to be higher, so phi k is going to be bigger than 1. This will give us constant job finding rate across the income distribution, declining separation, and also declining job-to-job transitions. So preference, rho stands for discounting, G stands for the probability of death, and it's going to be expected discounted present value of flow utility. Consumption can be home production or real wages if you are employed. S is going to be the utility cost of search. Eta is going to control the level of the cost. So we're going to pin down eta E in such a way to match the average job finding rate, job-to-job transitions in the economy. And then phi B is going to tell you how much you are going to adjust search intensity, that is denoted by S, whenever the real wage move. The main idea is we're going to go and target how search intensity goes down whenever you increase salaries to pin down this guy. R is a cost of renegotiation, like Fisher 77, and the main idea is going to enter in the utility of the worker, so the worker is going to choose when to renegotiate, okay? So, shocks that stick to the worker, you're going to born, and you're going to have a permanent productivity, draw and bear, that is at birth, that is a normal distribution, and then over time you're going to be shocks, you're going to have shocks. Gamma E is the drift when you are employed, we're going to target how much wages increases during the life cycle, and sigma is shocks that sometimes you have good luck, sometimes you have bad luck, and this stick to the worker. Here we're going to target the dispersion of income when you're old. Finally, gamma U could be human capital depreciation during unemployment. Okay, how jobs are going to be created and extracted in this model? So we're going to have directed search. So search is going to be directed in markets by productivity and real wages. And we're going to have free entry condition in each market. So the left-hand side here is the cost of posting a vacancy. It has to be equal to the firm's expected value of finding a worker. The matching function is going to be Cobb-Douglas. And notice, in our model, is going to depend on the number of vacancies in that submarket and also the search intensity. That is going to be not only the guys that are unemployed, but also the guys that are employed and how much effort the search intensity they're using. So market tightness is the ratio. The worker matching rate is going to increase with search intensity and the firm matching rate. Notice this. In our model, the relevant object for market tightness is search intensity. But in the data, what we are going to see is aggregate vacancy and unemployment. In our model, unemployment is going to be almost constant. So what is the way we're going to generate larger vacancies? We're going to say, following an increase in inflation, search intensity goes up, and these guys are going to get less greedy, so they are going to look in lower real wages, and therefore market tightness and the firm value is higher. So matches can be unilaterally dissolved by either the firm, and we're going to call this a layoff, or a worker, and we're going to call it quits. On top of that, we're going to have exogenous separations that are going to be IID with a probability that depends on the worker productivity. So inflation is going to be constant. Real wages of employed workers is going to go down with inflation. We're going to assume that new higher wages are perfectly flexible. If there is an inflation shock, it will not affect in which market I'm looking. And now what about renegotiation? We're going to assume that if we renegotiate, there is going to be Nash bargaining, where the also option is unemployed. Basically, what do you see in the data? In the data in wages relative to prices, you see many wage changes at around 3. How do we generate this? We assume that with some arrival rate beta pi, you're going to have a free opportunity to increase, let's say, to 3%. And then with other probability, beta plus, you're going to have a random cost to go and have a big wage increase in the job. We're going to calculate almost no wage decreases. And for now, in the paper, we assume that the weight following bargaining is going to be the same as the matching function. So markdowns, conditional of entering the job, are going to be the same condition of negotiating. Okay, what are the choices and values? So U is going to be the value of an employed worker with productivity C, and this guy is going to choose two things: the entry wage and the search intensity. H is going to be the value of an employed worker with productivity C and real wage W, and he has to choose 3 things: the target wage for on the job and search intensity, also to pay or not the cost for bargaining, and when to quit the job. Whenever, like, the threshold for quitting. The worker, so the firm is going to choose when to lay off the worker, so this is going to be a threshold policy, and theta is market tightness. So here, basically, you can see all the choices of the worker. So the flow value, the annuity of being an employed worker is going to depend on the flow income. Then you're going to have shocks. You are also going to have a decrease in the real wages, exogenous separations, the freebie, that is the 3% that we can increase. And then you have the possibility to renegotiate wage up if you choose to do it, or renegotiate the wage down. And you're also going to choose how much on the job search and where to look for. Okay, now let's understand how this model works. So here in the x-axis, we are seeing markdowns and the value of the worker relative to the opportunity cost, that is unemployed, and the value of the firm. The blue line is the value function of the worker. The red line is the value function of the firm. A is the entry point. Basically, it's when an unemployed worker looks for a job, he's going to enter in A. When these guys start getting employed, just 3 things can happen: trend inflation, idiosyncratic shocks, or inflationary shocks. So basically, they're going to move over the markdown distribution. Notice this: if the markdown starts going down, basically the worker will quit. If the markdown is going up, the firm will lay off the worker. There is a point, again, a worker in principle will always like more wages than lower wages. Why? Because your income is higher. The main problem is whenever you start increasing wages, you're also increasing the probability of layoff. So the point that maximizes this trade-off is B. This is the best markdown for the worker. Now, once we understand this, we can go and understand choices. Notice this. If you have a markdown below A, now the worker knows that condition of bargaining is going to go to a point with higher utility for him, for higher value. So that's why here you see that whenever you go below A, the hazard rate renegotiation is going to be positive. Now, let's go to, for example, if you are above A. If you are above A and you are a worker, you say, no way I'm going to pay the renegotiation cost because my value in here general is going to go down. Notice this: B is the optimal markdown for the worker. So when this guy starts going away because of shocks, inflation, and so on, this guy is going to increase both search intensity and also is going to become less greedy. Here in the right panel, we can see the target wage markdown. The main idea is when markdown starts to go down, the guy needs to choose a trade-off between job finding rate or show-to-show rate, and wages. The lower is your markdown, the lower is going to index trade or wages, so you're going to go down. And notice, here what do we see? Okay, the hazard rate of show-to-show mobility is increasing the distance with respect to the maximum value, the maximum markdown for the worker. Now, basically, in this model, there is one equation that explains everything. Imagine that now there is an inflation shock. You are in a markdown, let's say, below A, and there is higher inflation. The first thing is your real wage is going to go down, your markdown is going to go down, so you're going to become less greedy in which market to look. Because this point is below A, the firm value is going to go up, so market tightness in my model is going to be higher, so higher vacancies. On top of that, when the markdown goes down, search intensity is going to go up and also show vacancies. Therefore, our model can generate an increase in vacancy without moving unemployment only as an outcome of moving the distribution to the left. Again, this is like qualitative, so let's try to go and put some numbers. So I already told you how to parameterize the model, so let me skip this. But basically, the model does a good job in replicating heterogeneity across workers and the distribution of wage changes. Remember, these are base salary wage changes. So here, something is the data, let's say the red line, and the blue line is the model. Notice that the model can change the asymmetry of wage changes together with the mode to be at 3%. Now, in this model, we're going to go to calibrate 2% inflation, and then one day we wake up, remember the first experiment, preference, technology, nothing changed except the prices in the supermarket. I cannot do this in the data, but I can do it in my model. So one day we wake up and inflation is 13%. And this is MIT shock. And I'm going to focus only in this exercise, but in the paper we have also a sequence of MIT shocks. Here, non-NYU shock, okay, or Minnesota shock. So what do you see? Again, wage stickiness will imply that the markdown distribution will move to the left. So in principle, we're going to see less layoff and higher quits. And what do we see? We see exactly the same as you have in the data. There is going to be a surge in the vacancy to unemployment ratio. Again, not mainly because unemployment moves, but basically because vacancy goes up, and we're going to see a decline in real wages. Why do we see the increase in the vacancies? Basically because now search intensity is going to go up, my wage goes down, so I'm going to start looking, I'm going to put a lot of effort in looking for a new job, but also because I'm going to become less greedy in levels. These two decisions will give me the higher show-to-show. Notice the fact that in levels, markdowns are going down, it doesn't say the changes. So here we can see the monthly frequency of wage increases. Again, we don't have data counterpart, but in our model it's going to go up. Remember, the hazard rate of realization is asymmetric. And here we see the wage changes of job stayers and job switchers. As in the data, why we see people moving across jobs? Because it pays off. Again, in our model can replicate different wage dynamic across the income distribution. Why? At the end of the day, in this model, you're going to have higher show-to-show transitions for low-income people and higher separations. They would say, yes, higher opportunity to adjust wages. So therefore, the first quantile of the distribution is going to recover much faster than the last quantile. Okay, let me skip this, given that we have 1 minute. So, and again, it is nice to provide models to explain one episode, but the whole point is like, imagine like a Prescott STD standard deviation. We want to explain empirical regularities. So here, what you can see is the market tightness when you go until, whatever, 1950. What do we see? red circles are going to be periods of high inflation, of high increase in inflation. Again, we're not saying by no means that high market tightness is always associated with high inflation shocks. It could be the case that there is high marginal product of labor. But what we do say is whenever we see inflation, we see an increase of market tightness. What is the main takeaway today is, remember, search and matching models was designed like 85 Mortens and 94 Pizarrides. It was during the Great Moderation. So we need to understand how inflation will distort these models. And again, I believe this is important for policy.
Jim Mackey from Bank of Canada is the discussant.
Great, thanks for having me here. It's great to be back. It's a bonus to be back for a great conference too. So this is really really nice. So it's a great paper. I'm going to actually try to give a bit of a narrative, more from the point of view of Canada. So I want to talk a little bit about Canadian data. And I guess maybe the takeaway will be that the evidence from Canada is a bit more mixed about how important this channel could be. But also there's some evidence that suggests that some of this sort of mechanism that sort of fall in real wages driving people to search more to drive vacancies could also be potentially at play in Canada. But we'll come back to how much that is. Now, just coming back to sort of the ending point, this was a big policy question, a big policy debate. Now, of course, it's obvious that we had a very successful disinflation in both countries. We were down what looks like a very stable beverage curve that looked like very much like what we thought it looked like before the pandemic. But when those decisions were made in 22 and 23, it was not at all clear that that was going to be the outcome. And so there really is a sense here in which coming back to try to disentangle why we saw that pandemic shift in the beverage curve is actually very, very helpful for policymakers and very helpful for how we think about this. And so I think this approach of saying, well, let's take labor search models very seriously and think through how that's going to give us some insight into how these forces to play out is actually very, very helpful and very useful in thinking. And so I'm going to start off by saying this is a really nice paper. I really enjoyed reading it. And actually, I mean that, even though it's a very nice thing to say. It's actually true in this case. The model is very clearly laid out. All the pieces are really well explained. There's a very tight connection between key data facts, key model moments. The calibration is very, very nice. Now, you can also come back and say, well, what do I need to? It's a paper about wage adjustment, slow wage adjustment, so I'm going to put a lot of time into very specific assumptions about the wage adjustment process, but that all makes sense here, right? We're trying to build a model to really impact this episode. Now, I'll come back to this point here just before I get to the Canadian data and just say something that there's sort of a takeaway, one of the comments in the paper, looking at labor markets holistically and thinking through not just one measure. And that's something that the Bank of Canada was doing throughout the crisis, was actually having a wide range of labor market indicators that we were looking at. The challenge, of course, is you get a whole bunch of labor market indicators that sometimes point in different directions. How do I put them together to come up with a narrative of what's going on? Well, that's where having some underlying theory is really helpful. And I think this paper actually gives us one more piece of intellectual framework to actually walk through some of these data we saw. Okay, so what about the Canada case? I want to try to convince you or show you some pictures that says in many ways all the headline numbers about the jump in vacancies, the path of inflation, path of real wages look very, very similar. There's some limitations in the labor force survey, which is our equivalent of the CPS, that will make it a little bit harder to be really clean on EDE transitions, but to the extent that we can look at labor market flows, it doesn't look like there was a jump in flows. It doesn't look like there was a jump in EDE transitions from the snapshots we have from the private data, which then comes back to a little bit of how important was this channel in sort of driving the overall story. And there's also some of these other standard things you look at that are other big forces that we're trying to unpack. Now, one thing I'll come back at the end when we sort of come for a takeaway is this is a very nice theory. In the paper towards the end, they sort of say I can get about a quarter of the rise in V over U in the US, I think with the gradual inflation shock. And that actually is something you might look at in two different ways. You might say, oh, this is a small part of the story, or this is a significant part of the story that helps unpack part of the puzzle. And I'm much more in that second story, that this is an important piece, but I think these other factors are also a big part of driving some of the weird labor market dynamics we saw. Okay, so two headline charts on your left. So there's the inflation rate in Canada and the US. I'll try to stick with red is going to be Canada, blue is going to be the US. And so you see something where the timing of the surge in inflation in the two countries is very similar. The fall is also very, very close. We're maybe a little bit happier to say that we're closer to 2. We've dipped below 2. We dipped a little bit above 2, but we're a little closer to the target now. At the same time, on the right-hand side, you'll see that our measure of our vacancy rate also very much tracks the US. There's a level difference that's very persistent through time, which I think is potentially coming from different ways of doing the survey. But we see the same surge and the same sort of decline in that vacancy rate. And we've also done some charts I'm not going to show you, but if you look at what this means for the shifting beverage curve, you get something that looks very much like what you see in the US, the beverage curve shifting and then bouncing back in 2022 to pre-pandemic. Now, what about real wage growth? So I'm going to do something really simple. I'm going to take year-on-year wage growth minus year-on-year inflation, and I'm going to get a real wage growth. I'm going to take the Atlanta Fed wage tracker for the median worker, which I think was shown in the paper. For the LFS in Canada, we can't do exactly the same thing. And the problem with the LFS in Canada is they only ask you when you come into the survey what your wage is, and there's not a second question unless you change jobs. And so what people have done at the bank, some of my colleagues have said, well, what we'll try to do is go through and we'll create an average wage conditional on observable characteristics like age, education, and basically construct an average wage once I control for that composition bias. And that's particularly important during the pandemic because if I don't control for that, I see a big spike in real wages in 20 and 21 as a lot of low-wage, low-skilled workers left the labor force. But once I control for that, I get something that's much more closer to what we think should be going on. And what we'll get in this plot here is actually the following, that during the pandemic, real wages in Canada tracked very closely to the US, and then in 2022, things come up very much like we see in the US. What's also reassuring is this period following 2015, where we had a very slow domestic economy, in large part following sort of the slowdown in energy investment after the oil price fell. We actually see something where our real wage growth is a bit weaker than the US. So this seems to speak to something where that sort of the longer term macro trends show up when we expect them to, but during the pandemic, it looks very, very similar in the two countries. Now, there's another comment, which I think we can interpret this as being supportive of the narrative that firms did find it hard to hire. It's not just a V over U measurement issue, that we do a lot of surveys, and actually I've got a site to, you can't see the hyperlinks, but I mean, other people like StatsCan also did surveys of firms during this time period. And there certainly is something that shows up during the pandemic that if we look at measures of, how hard is it to hire, the fraction of firms in our surveys that's saying it's harder than usual to hire, or some measure where we sort of do an average of how intense is your labor shortage, you see this spike. Now, there's also a point here which these spikes are not necessarily that much higher than they were pre-pandemic, sort of in 2018, before we hit the shocks. But there certainly is evidence that firms felt like it was really hard to hire as well, consistent with the narrative that you're posting lots of vacancies and not getting lots of people showing up. But what about this sort of story about what happened to the EDE flow or flows in general? And so I think this great resignation story was something that showed up in the US media during this period. People talked about it in Canada, but when people actually try to dig, it's not a lot of evidence there's a great resignation in Canada. Now, a challenge in sort of getting something really clean here is that the public use files for our labor force survey are cross-sectional only, so there's none in the history. So I can see things like tenure and current job, which is going to be a proxy for if there's a lot of newly hired people, they're going to be short tenured. And then using that, we can also look at things like the hiring rate. And now, the second big bullet here, or in here, but snapshots. In the private data, the confidential data, you can actually look at the entire 6-month history in the LFS. And so you can actually see the people who change jobs, go EDE. Some of my colleagues, as part of this sort of producing these periodical snapshots of labor market conditions, actually were able to use that to say, well, what's happening to the EDE transitions? And what you'll see is that pre-pandemic, it's about 0.69% of workers going EDE in Canada each month. In August 21, there's a little of a spike to 0.76, but very quickly by 23, we're down below pre-pandemic levels. Again, if we kind of look at things like the fraction of people with short job tenures, that falls. If I try to do a hiring rate, which captures both EDE and UDE, or out of the labor force to employment, based on sort of tenures in the cross-section, that also stays below pre-pandemic levels throughout this period. So one of the puzzles in many ways for Canada is that we actually had this world where vacancies were high, hiring rates were actually a bit low across the board, and there doesn't seem to be a lot of separations don't seem unusually high either. So part of the mechanism seems a bit missing in Canada. Now, one thing that's very different about Canada is we actually had a surge in population starting in 2022. And part of that reason for that surge in population was because the government said, oh, labor markets are really tight, so we're going to basically really open up the door to temporary workers. We call them non-permanent residents, NPRs, in sort of the Canadian lingo. And so you have this very rapid surge at the bottom of the labor market. So it's very much younger people, less educated than the Canadian average. To the extent that you actually look at their wage discounts, you actually see that this demographic, actually one of my colleagues actually gave this paper recently using the confidential data. The discounts on those NPRs relative to Canadians actually went up. So their wages fell relative to Canadians, relative to similar-looking Canadians in this time period. So there is something else going in the market that may have disrupted the channel, but a lot of the other pieces all look very, very similar. Now, I'm just going to make this quick comment, which in a way is a bit unfair, but it actually comes back a little bit to sort of thinking about that distribution you start with when you hit the inflation shock. And this is just a reminder that we saw this big shift across sectors that was very pronounced and very prolonged in Canada. We don't get back to consumer expenditure shares on things like food, beverages, and services until 2023. And that's a bit longer than the US, in part because our lockdowns kept going all the way through 2022. But that also means at the same time we're talking about this shock driving real wages down, we're also seeing a real mismatch of people across industries, across sectors. Some of them moved during the initial pandemic, some of them didn't, but there's sort of this sort of pent-up desire to move. And again, in many ways for me, is puzzling in Canada is we did not see a lot of that labor mobility. Right? If anything, it was a very prolonged period of slow mobility. The other comment I'll make here, which is about, if I look at other measures like total hours per adult that are worked in the labor force, we saw a huge fall in 2020, actually should be more like 8, not 9%. By 2022, we're basically back to pre-pandemic levels of hours worked. So if you were looking at this from a narrative of something's happened where people went out of the labor force and they came back, that coming back is complete, but now we're seeing this other sort of inability to fill vacancies, low hiring rates, but it's because most people seem to be back in the labor force. Now, I'm going to give one more chart here about wage heterogeneity, or heterogeneity in real wages. And so, again, this is taking the same sort of clean average real wage series that we've built here at the bank by some of my colleagues. And the green line now, so the red is still the Canadian mean, the blue is private sector workers, the red is public administrative workers in public admin. And what we see is actually for the public admin sector, you see a much deeper fall in real wages. And remember, this is real wage growth, so that cumulative gap in real wages actually builds up to be much bigger. I think it's like 7 or 8 percentage points by the end of 24 compared to the private sector. Now, part of what's happening here is actually that part of the jump in vacancies in this time period is actually in health and education, which is sort of this government-controlled sector where real wages are actually growing even much more slowly throughout 22 and 23 than in the private sector. Now, one sort of different comment coming back, what else can we look at to sort of back up the story that part of what's going on is we've seen a surge in vacancies targeted at people who have jobs. Well, one proxy for that is to go to the job ads and say, well, which job ads are targeted at people with multiple years of experience? And that's not perfect because sometimes you post for multiple years of experience expecting to hire from the pool of unemployed, but presumably we're seeing a relatively bigger jump in that sort of pool of I'm looking for people with 3, 5, 10 years experience. Presumably that's reflecting sort of this E to E search intensity going up for firms. And so there's a little bit of evidence that some of this is going on, but it's only a part of the rise in vacancies, it seems, at least in the Canadian context. So where am I going to close with is sort of, again, where we started. We saw this huge shock to the economy. It was a huge challenge for us sitting there throughout the pandemic and trying to unpack what was going to happen, what would happen as we tighten monetary policy to bring inflation down. And a lot of it was sort of a world where the discussions were very, very uneven. And so in many ways, I think actually this paper would have been very helpful if we'd had it in 2022. I think it's going to be very helpful in the future as we go through other types of shocks. But I still think there's a question at the end, and again, this is sort of maybe more for future work, of trying to go through and quantify the relative importance of these different forces, and then how do we line them up with slightly different experiences across countries. So on that note, I'll end. Thanks very much.
Thank you, Jim. Questions from the audience?
Hi, Jorge Herrera from the University of Minnesota. In the model and most of the data, you show that like market tightness is mainly explained by the increase in vacancies. But for what I remember of like the episode, there was also like this decrease in unemployment because people actually exited the labor force and they were not looking for a job anymore. And of course, you also had these massive transfers from the federal government. So people were leaving, like they were scared of coming back to work because they were scared of COVID. And they also had like extra income because of these transfers. So should we include somehow these like extensive margin shift in the model or in the mechanism? Thank you.
Can we have Jonathan?
Thank you. So in the model, I guess there were two features of wages which, I mean, maybe they're connected to data, but sort of in the model, in the model, so you assume that wages are fixed in nominal terms. I guess if they were fixed in real terms, then the mechanism doesn't work. But so maybe the data just is that they don't seem to be fit. I guess the second feature of the model, which I'm not sure what the data says about, is that I think in the model, if you get an outside offer, if you do on-the-job search, get an outside offer, your current firm doesn't respond. They don't try and raise your wage and retain you. But maybe in the data, I mean, I think there is some of that. Incumbent firms do try and retain workers, and we try and match outside offers, for example. But then, that would be a natural thing to do if the match is still, all your firms are the same. I think they're equally productive, so the surplus to the incumbent firm of retaining the worker would be positive. And I guess that would, if there was that kind of offer matching kind of retention strategy going on, then maybe you'd get fewer job-to-job transitions and so on.
Sort of related to that, I think if I understood, I didn't understand the full model, but if I understood it correctly, if I get a new job at a work site, the other people at that place don't get an increase just because a new worker came in at a higher wage. So I think an implication of your model is that the dispersion in wages between the new hires and the existing low tenure workers explodes in these periods. Yeah, you don't have firms, but I mean, if you think your model is a model where every job is a single firm or whatever, but in reality, there's a lot of evidence or discussion about whether the way wage setting works affects groups of workers or is all idiosyncratic, and it seems like you might want to look at that in the data.
This is Abby Wozniak. Just thinking a bit back to the very end when you were talking about historical episodes and comparisons. I think I read your slide as thinking of it as a mixed story, some success, some not success. Maybe I misread and you want to argue for very successful. So just wanted to hear more thoughts when you can on how you did historically.
We have one more question, Richard. Can we get him? Oh, go ahead.
So yeah, one question I had, it seems, if I understood your model correctly, that all workers can do in your model is always catching up with inflation. So it seems you have like completely shut down the other channel that's present in many DSGA models. That would be, wages actually pushing up prices. Is that correct? And, is that something you could like look more into? Because that seems, it was also part of the story, at least in policy circles, that wages were also feeding back into inflation.
Any other questions? All right, Andres.
Hi. Okay, first, thanks for the discussion. I love to go to the Bank of Canada. I went when I went to the job market, and now like 1 year ago. So let's go. So you present some evidence that it was harder for firms to find workers, or model also predict that. I didn't present this today, but the time that the vacancy is posted is going to go up. Okay, then there was a lot about reallocation and amenities. By no means I'm saying amenities didn't matter for wage dynamics during this period. We have one picture in the paper where you see like occupations that have a lot of amenities or work from home versus no work from home. And basically what happened is, following the inflation surge, the guys that have no amenities, amenities both like went down, and then there is like a parallel trend where the guys that have amenities went even down more. But again, the fall and the recovery, like the dynamics, seems to be like parallel shift. So again, for sure, dynamic of wages matter for amenities, matter for dynamic of wages, but for the dynamics of up and down, again, I don't know so much. Reallocation. We did a lot of work with reallocation, and for this, like what I call like, you are so lucky. Basically, when I start looking cross-section, I love this part. We start looking like correlation, okay, industries that, during this period, industry that you have higher quits used to have also higher vacancies. Again, it is in one paragraph footnote in the paper, but I believe this provides like a lot of evidence saying, look, whenever we see a lot of job mobility, this is associated with higher vacancies. Public workers, again, I believe this is another story. Labor force participation. I don't remember correctly, but if I remember correctly, basically what happened is you have labor force participation, COVID hits, it falls, and then it comes back. I don't remember exactly the level, but my own guess for 2022, labor force participation was almost in the same level. Again, I need to check it back. Okay, someone asked about nominal wages. Yes, if real wages, if wages are like, if you can go and make a contract where wages are correlated one-to-one with inflation, then no more mechanisms. Even more like, we go back to, I don't want to say Barrow because, no, but you know what I mean. External offers. If you tell me the original thing that we have when we start thinking about this model is we only focus in shocks that stick to the worker, but not shocks that stick to the match. And we didn't thought about ex ante like match heterogeneity. Post-terminate. Again, by no means I'm saying this is not important. What I'm saying is, look, we need to start some way. I remember when we were thinking about this in 2020, McGill has this paper saying that shocks that stick to the workers are the most important for labor income risk, and we wait this direction. But for sure, again, the model that I would like to see is a model where the base salary seems to be more attached to external offers, and that's what gives the dynamic of that. That will be my, whatever, I love model. We're working on this, I keep you posted. That's all.
And
We're working
return
on that.
here at 2:55.
All right, thanks. So next up, we have Brian Stewart from the Philly Fed, who's going to present dynamic individuals, static neighborhoods, migration and earning changes in poor neighborhoods.
Thanks very much, Dan, and thanks very much for including our paper on the program. I'm happy to be sharing work that's joint with Andy Guerin, Ethan Jenkins, and Evan Mast. Of course, the usual disclaimer applies. So the starting point for this paper is an observation, which is that neighborhood poverty rates in the United States are extremely stable. To give you kind of one cherry-picked example, if you look at neighborhoods that have a poverty rate of 30% in 1990, and then you ask what is their average poverty rate, and essentially every year between 2000 and 2019, the answer is 30%. That's a lot of stability in average neighborhood poverty rates. And when you think about that, there are two sets of explanations. One explanation is that we have a situation where just residents of poor neighborhoods stay put, they stay in those neighborhoods, and they don't experience much income growth. That's a story of static neighborhoods and static individuals. And it could be consistent, for example, with people facing non-income barriers to migration because of segregation or discrimination, for example. A very different story is that instead what happens, the people who experience earnings gains leave those poor neighborhoods, and you're essentially left with people in those poor neighborhoods who didn't experience those types of income gains. That could be consistent, for example, with research showing that the demand for neighborhood quality is increasing in income. So I think those two different views of the world have important implications for how you think about poor neighborhoods and cities, place-based policies. And I think it's pretty clear that to unpack that, we need information on individual level dynamics that underlie what's going on within neighborhoods. That's what we're going to do in this paper. We have access to comprehensive administrative data from the Census Bureau. Shout out to the Census Bureau. I think this is, a lot of papers today really rely on this, so thank you folks at the Census. Where we have administrative data with people's neighborhood of residence as well as earnings on an annual basis. This is going to cover essentially the vast majority of the US population. With those data, we're then going to estimate 3 sets of moments that are key to understanding concentrated poverty. We're going to look at how often people move out of richer versus poorer neighborhoods. We're going to look at earnings growth rates for individuals that start out in richer versus poorer neighborhoods. Then we're going to bring those together and try to look at the effect of changes in individual income on changes in the type of neighborhood where people reside. We have a lot of data, and so I'm going to show you kind of our starting efforts at looking at heterogeneity along individual demographics, and then I hope to have time at the end to talk about what all of this means for policy. The broad takeaway that I'm going to kind of show is that there are a lot of individual level dynamics. So going back to this story, static neighborhoods, dynamic individuals, by far seems to be the best way to kind of rationalize the patterns that I'm going to show you. We see this as fitting in with kind of 2 broad sets of work. First, there's been some really nice work thinking about migration in poor neighborhoods. Some of that, I think of kind of the first wave, relied on the PSID, which is of course wonderful and great, and has limited sample sizes and kind of limits our ability to look at heterogeneity. There's also been some really nice and high-profile work looking at specific housing safety net samples. That's of course super important, but just a subset of the individuals that live in poor neighborhoods. So we're going to be able to kind of widen our scope with the data that we have. By contrast, I think there's much less work thinking about how earnings dynamics relate to the neighborhood where people reside. And so our contribution there is going to be, I think, even more clear. There's also some really nice work thinking about neighborhood change, how often neighborhoods change, what it means when they do, and why. To that literature, we're going to contribute this individual level understanding, which we think is really important to kind of tease apart potential explanations for what might be going on. And I think at a high level, what we're going to take away from this is kind of similar to what we've learned over the last decade or so when we started to think about individual level data and how that can help us understand neighborhood gentrification. I think a lot of those kind of the same flavor of insights will come through in what I have to show you today. Okay, so we're going to use 3 main data sets. The first is the master address file, which essentially gives us the housing unit of residence for a near population of everybody that lives in the United States. Think of this as essentially the Census Bureau trying to ingest all of the information that they can from tax records, health records, USPS change of address forms, et cetera, to try to identify where each person lives in each year. Second, we're going to use the American Community Survey. That's going to give us really important demographic information, characteristics of people's household. And then we're going to use the LEHD that Dave was using as well that gives us, this matched employer-employee data, where we have quarterly earnings and employment and employer characteristics. We do not have a census co-author, and so we're going to be limited to 25 states in our analysis, but that's broadly representative of the country at large. So the way that we're going to construct our sample is by starting with people who responded to the ACS between 2005 and 2013. The ACS is essentially the backbone for what we're doing. We're then going to limit to people that we think of as making active location choices. So these are people who are 25 and above, who aren't a full-time student, who aren't in the armed forces, who aren't living with their parent, or living in group quarters. And then we're also going to throw out a pretty small number of people that are living in a tract where 18 to 25-year-olds exceed 20% of the population. That's just to kind of clean up this phenomenon where people finish college and kind of hang around for a few years. So we're really trying to capture people at kind of the start of their adult migration and earnings trajectory. The way this is going to work is we're going to see people in the American Community Survey, and then we're going to link the master address file and the LEHD to the ACS observations for a period that covers 3 years before the ACS and 10 years after. So that's going to give us basically a 13-year window over which we can observe earnings and migration dynamics. We're going to use two main samples. Our migration sample has about 13 million individuals in it. For this, we're going to further restrict ourselves to people that answered the ACS between 2005 and 2011. And we're going to do that because we want to have essentially a balanced panel to look at 10 years of location choices for everybody in our data. The earning sample is smaller at just under 2 million individuals. And so what we're going to do is look at the ACS respondents who are in the LEHD states that we have. Then we're going to, for now, apply some sample restrictions from the earnings dynamics literature. So we're going to limit to people age 55 or below to essentially minimize the role of retirement in the patterns that I show you. We're also going to require that people be working half-time in the ACS when we observe them. And we're going to drop these extreme LEHD earnings observations that are particularly low or particularly high. I'll say I think these restrictions kind of follow this previous literature that's focusing on earnings dynamics. We're going to relax a bunch of those going forward. So I think especially when you're thinking about poor neighborhoods, we want to have a broader picture, and that's what we're working on once we can get back into the RDC. Some other important notes. We're going to be using constant census tract boundaries over time. And especially important is that we're going to keep neighborhood characteristics fixed. So we're going to measure, for example, the poverty rate of a neighborhood from the 2005 to 2009 ACS. We're going to keep that fixed. Otherwise, it'd be kind of hard to interpret if you see people leaving a neighborhood and then the poverty rate in that neighborhood changes because of that migration. That's just kind of a complication in interpretation that we want to avoid. If you were to pick a different set of years to fix neighborhood characteristics, all of our conclusions would be very similar. So things are not so sensitive to that. Okay, so now I'm going to show you our three sets of results. The first thing I want to show you is how people move across neighborhoods. And this is a figure that shows you that migration rates are higher for people that start out in poorer neighborhoods. So let me kind of orient you to this figure, because I'll show you a few that look like this. On the y-axis, we're showing the share of people that remain in the baseline census tract. That's the census tract when we first observe them the year that they complete the ACS. We're then going to follow people over a 10-year period, and this graph is showing you the share that remain in that baseline tract for 4 different groups of people, based on those who started out in a census tract where the poverty rate was below 10%, 10 to 20, 20 to 30, or above 30%. And it's that above 30% poverty rate that we're going to focus on kind of the high poverty set of neighborhoods. So if you look at all of the people in our sample, 43% of people moved to a different census tract over this 10-year period. If you look at people that start out in a high poverty census tract, that number is 51%. So there's a lot more migration out of poor neighborhoods than there is out of rich neighborhoods. Now, I think a possible reaction to this could be, well, look, we know there's a lot of volatility and churn for people in low-income neighborhoods. So maybe people are leaving their poor neighborhood and just moving to another poor neighborhood. That turns out to not be kind of the predominant feature we see in the data. Instead, what we see is that most people who leave a poor neighborhood move to a richer one. The way that I'm showing you this here is just by giving you a slice of a full transition matrix, where we're starting by looking at people that are in a neighborhood where the poverty rate exceeds 30% in the year that we see them in the ACS. And then we're asking what type of neighborhood are they in 8 years later. And you can see that 63.5% of those people are in a high poverty neighborhood 8 years later. That just means that 36.5% of those people are in a less poor neighborhood. And if you combine that with the migration rates that I showed you on the previous slide, you get that 81% of people who leave a high poverty neighborhood move to a richer one. Kind of the same picture and everything that I'm showing you works if you instead look at neighborhoods by, say, quintiles of median household income. So there's a lot of moves out of poor neighborhoods. Most of those moves are to richer neighborhoods. We have this longitudinal data, and so we can do a lot more than I've shown you so far, and I'll just kind of give you a flavor of that. What we're going to do now is to think about people that are living in a poor neighborhood, and we're going to ask how many of the next 10 years do they stay in a poor neighborhood. That's how we're going to think about exposure to concentrated poverty. And I'm showing you here that 31% of people who start out in a poor neighborhood spend 5 or fewer of the next 10 years in a poor neighborhood, while about 54% of people spend all 10 out of 10 years in that high poverty neighborhood. And so that basically tells you we have this bimodal distribution of exposure to concentrated poverty. If you look at people that leave their high poverty neighborhood, on average, the poverty rate of the neighborhood where they reside falls by 24 percentage points. So people that leave high poverty neighborhoods move to substantially less poor neighborhoods. Now we can do this for a bunch of different individual demographics in our data, and I'll just show you kind of a few of the patterns that we see. I'm going to focus on the column in red here, which gives us what share of people have essentially full exposure to concentrated poverty. And so you can see, for example, that younger individuals, aged 25 to 35, about 31% of them have full exposure to concentrated poverty. For older individuals between 45 and 65, that share is twice as high. We're especially interested in differences by race and ethnicity, especially given some of the previous work in this area. And we do see that Black and Hispanic individuals have higher exposure to concentrated poverty than white individuals, but the gaps by race and ethnicity are quite a bit smaller than some of the other gaps that we see along these demographic patterns. Those are not so large. For example, if you look at people that are a homeowner when we see them in the ACS, 2/3 of them essentially have full 10 years of exposure to concentrated poverty. For renters, that number is more like 40%. I think all of these patterns basically make sense and are kind of what you would expect. And then in part because of this research showing that there's really important consequences of growing up in a poor neighborhood for children's long-run outcomes, we were interested in how these patterns differ for people who are parents or not. And what you see as you kind of go down these rows is that exposure to concentrated poverty is the highest for people that don't have kids when we see them in the ACS. And indeed, it's the people that have kids and are relatively young, so in turn who have kids that are relatively young, who have the lowest amount of exposure to concentrated poverty. Okay, so that's kind of one set of results showing that there's a lot of migration out of poor neighborhoods into richer neighborhoods. I next want to show you some results on earnings dynamics. I'm going to start with kind of the simplest possible figure that I can, which is just a histogram of 8-year changes in individual real earnings from when we see people in the ACS to 8 years later, broken apart by the type of neighborhood where we first see people. And so just at a, I guess, superficial level, I want you to see that like these histograms are pretty similar on net. You know, they're in all of these types of neighborhoods. We see people with large earnings increases and earnings decreases, and that pattern kind of shows up everywhere that we look. If you focus down here, these are people that start out in a neighborhood where the poverty rate exceeds 30%. Something like 20% of the people in those neighborhoods experience an 8-year earnings growth of $20,000 or more. So there's a lot of people in these high poverty neighborhoods that experience significant growth in their earnings. Now we can look at this more formally by essentially just regressing the log change in earnings over this 8-year period on indicators for the type of neighborhood where we first see people. And so in the first column, there's essentially no other controls. You can see that on average, this 8-year real earnings growth is around 10% for everybody in our data. And then if you ask whether or not that growth rate is different for people that start out in neighborhoods where the poverty rate was varied, all of those coefficients on poverty rate are essentially, those are poverty rate indicators, are small and indistinguishable from 0. So what that tells you is that basically earnings growth is the same for people that start out in richer versus poorer neighborhoods. That conclusion remains the same as we add more controls for the metro area, where we see people in the year, or for their race, age, and education. So the overall picture here is that earnings growth rates are very similar for people that start out in richer versus poorer neighborhoods. What we want to do next is to bring these stories together and think about how changes in individual earnings shape the neighborhood where people reside. And again, I'm going to start with kind of the simplest possible figure that I can. This is a bin scatter showing the average 8-year change in the tracked median income where people reside as a function of the 8-year change in individual earnings, separately for the types of neighborhoods where we first see people. So I'll remind you that we're using fixed neighborhood characteristics here. So if people don't move, this 8-year change in tracked median income doesn't change. That's a 0. Basically, the only way for these numbers to be different from 0 is through migration, given how we've set up the data. And I think the really striking feature that you see here is that for people that start out in a poor neighborhood, no matter what their change in individual earnings is over this period, they're moving to richer neighborhoods. And that's especially true for people that see increases in their individual earnings. You can see that upward slope on the right part of the graph. Now, that increase in neighborhood income as a function of individual earnings is especially true for people that start out in the poorest neighborhoods, but you see that to some extent in the other neighborhoods as well. Now, there's a lot of things that go into these 8-year changes in individual earnings, think life cycle factors, other things like that. And so what we want to try to do is to basically isolate the role of changes in earnings. And the way that we're going to do that is, in part, kind of building on ideas that we've already seen today, the fact that firms are really important for people's pay. And so we're going to try to isolate these idiosyncratic firm-level shocks that basically say because one worker is at one firm and not another firm, their earnings went up over this period. And that wasn't an anticipated increase in pay, and it wasn't because of systematic features of the worker. That's the kind of ideal experiment that we're going after. The way that we're going to do that proceeds in 2 steps. First, we're going to construct a leave-out firm pay shock for everybody that we see in the ACS. So what I mean by that is that we're going to go to people's coworkers who don't show up in the ACS. So this is an independent sample. We can do that because we have the LEHD. And then for their coworkers, we're going to measure the mean % change in earnings over a 4-quarter period. We're going to focus on people that work at a firm where they have at least 25 coworkers to kind of get away from some small sample noise issues here. Now, to be clear, that by itself is not enough, I think, to argue that we have these idiosyncratic firm-level pay shocks. But we're going to layer on a bunch of controls to try to get observationally similar people working at observationally similar firms. In particular, there's a bunch of individual and firm-level factors that we're going to interact with time-fixed effects. You can think of that as essentially allowing trends in the outcomes I show you to vary really flexibly over time with respect to these baseline characteristics. So for people, we're going to include their initial wage, the median income of the census tract where we first see them, as well as their age, sex, race, ethnicity, and education. We also have information about the firm where they work. Firm size, we have measures of firm pay, entry rates into the firm, exit rates out of the firm. So if you're worried that these are basically shocks that are preceded by changes in firm-level outcomes, we're going to try to control for that. And then we have some fixed effects for individuals industry by time, and metro area by time. So, there's a lot here. I think this is kind of an issue where the proof is in the pudding. And so let me show you that. I'm going to show you a few different event study figures where we've normalized the coefficient at -1 to be equal to 0. And so these are basically the pre-trends before the measured coworker pay shock. And then to the right shows you what happens afterwards. We've also scaled everything to report the effect of a 10% increase in coworker earnings. And so what you see, the kind of top set of estimates here in squares, is the impact on log individual earnings. And you can see that this 10% increase in coworker pay leads to about a 2.5% increase in individual pay on impact. That then attenuates somewhat over time, but even 8 years later, these are not cumulative effects, these are annual effects. So even 8 years later, the people that were at a firm that had a positive coworker pay shock have elevated earnings. Now, I think it's fair to think that maybe household is the unit of decision-making here for these kinds of location choices. And so if we do the same exercise, but with the log of household earnings, the story is very similar. That's the estimate shown in blue. And then in red here, I'm showing you the impacts on the probability that somebody's at the same employer. And so I think as you would expect, a positive coworker pay shock makes people want to stay at the same employer where they have been. I'll just note that kind of that by itself removes from the table one motivation for people moving, which is that now they have to reallocate, they want to reoptimize their commute because they're working at a different employer. Okay, I'm going to skip ahead to show kind of the impact on household earnings that I just showed you, alongside the impact on characteristics of neighborhoods. So the estimates in blue you've already seen. And what I'm adding to this figure now are regressions where the dependent variable is either the log of tracked median household income or the log of tracked median home value. Again, those are time invariant characteristics, so these things only change when people move. And what you can see is that basically as people experience this durable increase in their earnings, the quality of the neighborhood, as measured along these dimensions, increases. Now, to think about the magnitudes here, the average effect on household earnings is about 1.4 log points. The impact on neighborhood income at the end of this period is about 0.24. And so if you want to think about constructing an elasticity of neighborhood income with respect to household earnings, you divide those and you get a number of about 0.2. I think the thing that's very clear here, though, is that interpreting that elasticity is pretty tricky because of the dynamics that you see here, right? And that this is basically a large initial increase in earnings that fades somewhat over time, whereas the impacts on neighborhood quality kind of grow over time. Okay. I want to conclude by talking about some implications for neighborhood change and place-based policy. First, part of the motivation here goes back to Jane Jacobs, who was basically arguing that once you have a poor neighborhood, that poor neighborhood is going to continue because people who experience some gains in income move out. So look, I think this is like a really insightful idea based on deep observation about cities. Of course, Jane Jacobs had neither the joy or the pain of census administrative data. And so we can kind of take this to the data and see what this looks like. So what I'm going to show you is that a key reason why poor neighborhoods stay poor is because people move out of them when their income goes up. And the way that I'm going to do that is by, first of all, looking at people that start out in a neighborhood where the poverty rate is 30% or above or below 10%. And no matter where those people move, I'm going to measure the average change, or their average growth in their earnings over a 10-year period. So this is a fixed set of people that we're going to follow no matter where they move. And what you can see is that actually the growth rates in terms of earnings are very similar for people that start out in poor or rich neighborhoods. Now, I already showed you kind of a regression-based version of that, so there's nothing new here. But if we instead shift our focus to people that are living in poor neighborhoods or rich neighborhoods on an ongoing basis, we get a very different picture. So now what I'm doing with this ongoing resident series is we're looking at people in each year that live in a neighborhood where the poverty rate is 30% or above or below 10%. And you can see for the people that are living in rich neighborhoods, the trajectory of their earnings growth is very similar to when we just look at initial residents. But when we condition on people that are living in a poor neighborhood, that's the bottom line. We get a very different picture. Their earnings growth actually goes negative over this period, which partially includes the Great Recession. And then if you look at the end of the period, the earnings growth is a lot lower. And so the clear takeaway from this is that these dynamics of how people are sorting into and out of neighborhoods really matters. Okay, I've got 1 minute left, and so I just want to talk a little bit about the implications for place-based policy. I think the first thing that is very clear from our results is that if you're a policymaker, you should not equate current residents in a poor neighborhood with future residents in a poor neighborhood. There's a lot of moves out of these neighborhoods. And in part, that's relevant because at the moment, there are several guaranteed income pilots that are focused on residents of poor neighborhoods. Now, look, let me be clear. There are good reasons to set up these kinds of pilots that focus on people in poor neighborhoods from a research standpoint, as well as just kind of a policy motivation standpoint. I think what our paper shows is that a not very good motivation for that is because you think those people are just going to stay in a poor neighborhood if you don't bring guaranteed income to them. The second thing that I want to say is that policies that improve labor market outcomes for individuals in a poor neighborhood may not actually benefit the neighborhood itself. Now, I think some of the researchers here would say, well, that's fine. That's not our goal in these types of programs. We want to help the people. To that, I would say some policymakers do care about helping neighborhoods. And this process through which increasing individual earnings leads to migration to richer neighborhoods just means that some of those benefits are not going to stay in the neighborhood that's affected. And then the final thing I'll say is that, Jane Jacobs brought up this idea that maybe if we could just retain, people with positive earnings growth in these poor neighborhoods, then we could improve neighborhood income. And she was thinking about that as kind of a direct goal of policy. Our results show that, that is, I think, on the table as an empirical matter. The welfare consequences of that are kind of far from clear. Why you would want to constrain or incentivize those people to stay in that neighborhood when their income grows, not obvious at all. And of course, anything that you do to improve neighborhood quality could lead to higher housing costs, which is going to have its own effects on equilibrium sorting and affordability. So with that, I'll conclude. I think the key takeaway from this is that most residents of poor neighborhoods are not stuck. There's a lot of individual level dynamics that underlie these patterns of neighborhood stability. And in particular, this dynamic process is an important reason for why poor neighborhoods stay poor. Thanks.
Thanks, Brian. And next, Elizabeth Roberto from Rice University is going to discuss.
First, I want to say thank you for the invitation to come and discuss this paper. It was very thought-provoking, excellent research, very impressive data work here. I'm first going to briefly summarize the main contributions of the paper, and then I'm going to provide 3 main comments on the paper itself, but also future work that may grow out of this paper. My comments are mostly questions, which may be refreshing when we are used to having questions that are really comments. And I hope that they'll help the authors think about how they might extend this research in the future. So first, the central research question of the paper is, why do poor neighborhoods tend to stay poor? Do residents stay in poor neighborhoods and experience little income growth? Or do residents leave poor neighborhoods when their income rises, with lower income residents remaining behind? And this question has important implications for understanding individual migration patterns, the persistence of concentrated poverty, and adjudicating between people-based and place-based policies for alleviating poverty. The findings show that migration rates are higher in poor neighborhoods. The earnings growth rates are similar across neighborhoods, and there's a positive relationship between earnings growth and migration to richer neighborhoods. There's a number of implications. First, most residents of poor neighborhoods are not simply stuck there. Many experience sizable earnings gains and move to richer neighborhoods. In this dynamic process is an important mechanism in keeping poor neighborhoods poor. I see this paper as sitting at the nexus of research on neighborhood change, residential mobility, and neighborhood effects. And this is a literature that is shared both by economists as well as my discipline of sociology. So a key contribution is that migration and earnings dynamics of individuals in high poverty neighborhoods, as well as our understanding of how individual level dynamics produce neighborhood change. Additionally, a contribution is helping us to think about how we design and evaluate place-based policies. So now I'm going to get into my response to the paper. Okay, so my first set of comments/questions have to do with the mechanism. So this paper is framed as a puzzle about the persistence of high poverty neighborhoods. And I'd like to push the authors a little bit further and see them take up the question, perhaps in future work, of what about these neighborhoods makes them incubators of economic mobility? And for whom? Who experiences the mobility? In reading this paper, I was struck by the idea that these seem like pretty great places to live. And if I want my earnings to increase, should I move to a high poverty neighborhood? I think that that's not the story here, but I would like to see you dive deeper into who is experiencing the mobility. I think this question is critical for understanding the policy levers and who would benefit from them. Related to that point, one of the examples that you gave in the paper was about those who experience an earnings increase of $20,000 to $30,000 a year living in high poverty neighborhoods. And I was really struck by that figure. It seems huge to me. An earnings increase of $30,000 seems life-changing for many people living in high poverty neighborhoods. And so trying to understand who are the people for whom they could really experience that kind of increase. So also related to this idea of trying to understand the mechanisms better, what else other than population composition about these neighborhoods matter? Should we consider differences or changes over time in the built environments of these neighborhoods, such as the quality of housing or the quality of the infrastructure? What about the institutional environment of these neighborhoods matter, like access to public services and resources or kinds of networks? And also, as I'll get into in my next comment, what about the location of these neighborhoods and their proximity to good jobs? So finally, on this idea of more clarity on the mechanism and related to my own research, I wondered if residential segregation by race and or income at the city or the regional level creates the structural conditions necessary for these mechanisms to operate. So if we looked at residential segregation and how your results differ depending on these structural conditions, would we see that there's mobility that's happening to a greater or lesser extent depending on those levels? Okay, my next set of comments have to do with taking a spatial perspective. I am really impressed with the data that you have access to, and through the Restricted Data Center, I know that it's hard to take out spatial data in the sense of being able to produce maps, which I would love to see for this data. But I want to encourage you to, rather than thinking about these neighborhoods as categories, thinking about them as relational units, and trying to think about what is the spatial arrangement of these high poverty neighborhoods. How might it matter if a poor neighborhood is surrounded by other poor neighborhoods versus being surrounded by higher income neighborhoods. So how does clustering or the concentration of concentrated poverty matter for some of these outcomes that you care about? Next is thinking about scale. So you're using census tracts, which is, very common in the literature, census tracts as representing neighborhoods. But census tracts, you've got coverage across the entire US, they vary widely in size. So if we take a census tract in New York City versus a census tract in Wyoming, we're gonna see that the size of that tract or the size of that neighborhood is really quite different. And so what does that mean to have this unit of the census tract be our proxy for neighborhood in different parts of the US, both urban areas and rural areas? And so I would push you here either for this paper or possibly a future paper to try to look at if you can create more, if you can, for robustness, create geographically stable units and see how units of the same size might help us to understand these dynamics, and or also look at neighboring census tracts to see how the spatial configuration, spatial arrangement matters for the concentration of poverty. Next, and finally, I want to encourage you to think about both heterogeneity and intersectionality. So first, what does it mean to be white and poor versus black and poor? And when in your results you talk about those who those are able to move out of the high poverty neighborhoods, there are some people who are moving out and moving up into a lower poverty neighborhood, others who are not. They're moving out, but they're moving into a structurally similar neighborhood in terms of poverty, perhaps other kinds of institutional resources. And so are we seeing differences, not just controlling for race, but really looking at the intersection of race and other characteristics, like the household or individual's own earnings? And then next, are high poverty neighborhoods more heterogeneous in terms of earnings variation? And this was a question that I kept coming back to as I was reading the paper. Are these high poverty neighborhoods more heterogeneous? And is that especially true for neighborhoods that are predominantly Black or Hispanic? So it's possible that it takes a larger earnings increase to move out of a high poverty neighborhood if you're Black or Hispanic. So those residents may stay longer, and we might then observe bigger earnings growth in those neighborhoods because they stay longer in order to move out. And so this was a question I kept coming back to that I think is something that maybe could be taken up in this paper to really to think about. You tease that the next version of the paper will have more consideration of heterogeneity, and I think this question would be particularly apt if this earnings increase has to be larger in order for us to see Blacks and Hispanics moving out. Okay, thank you very much.
I'll go first. Can I? Okay, I think that was an excellent paper, but one question I had is about you focused on the trajectory out of the neighborhoods, and I wonder if you, in the paper, not focusing on the trajectory into those neighborhoods, and that would speak to some of these mechanisms like the Bilal, Rossi, Hansberg paper I think you had in there about using these low-cost neighborhoods as an insurance mechanism when you hit hard times.
Maybe you talk about it, but you showed this pattern on migration, like people move away from
poor neighbor into rich neighbor. But and you decompose it by race, other stuff. But I was wondering, how about income? So who moves out of a poor neighbor? Is the rich or the poor? Because it has very different implications of the neighbor. If actually the poor live then or below the median, then the neighbor gains from mobility. So I was wondering if you look at that.
Just general interest in how the homeownership channel works here and whether homeownership is a trap. I don't know that you can get at that with these data, and in particular, homes that might be bequeathed to people or that have been in the family intergenerationally. You may be able to get at something like that with some of the data you have.
Okay, that was an awesome paper. Thank you. One question I have is like, you have this result on income of ongoing residents going down. Did you unpack that? Like, do you have a sense of why that's happening? And like one obvious thing to consider is like small business activity and firm creation. Have you thought about that?
Yeah, I just had a quick thought on the policy implications for place-based policy and sort of whether or not we kind of think less of place-based policy if we know the people that are currently living there are going to have higher incomes in the future. It just kind of strikes me that if you're seeing low incomes precisely at the time you're choosing these types of neighborhoods, that could be a pretty good tag for a particular set of place-based policies that are helping people kind of in their kind of down and out moments, so to speak.
One other source of heterogeneity you could look at is I think you have the education of individuals, and I just wonder if maybe you see that the people who are able to move out of the poor neighborhoods are those who have higher education on average.
Okay, thank you for all the questions. Let's, Brian can take the next minute to.
Yeah, wonderful. So, okay, great. Okay, so maybe I should have said this at the outset, but we have basically used a small share of our overall census disclosure budget. And so Liz's discussion and your comments and questions are extremely helpful as we basically do the next set of results. We had not thought of everything that Liz described, but I agree that everything there is valuable. And so I'll just kind of highlight a few things. You know, I mean, I did nothing about like metro structure. Or for example, like the price of moving to lower poverty neighborhoods across metropolitan areas. That's a big thing that we're going to be looking at here. So far, we have been kind of holding off, like directly tackling racial segregation because we think a paper about race kind of needs to be its own paper. And so we've kind of done the lesser approach of that so far. But I welcome kind of feedback from folks at the break or tonight if you think we should go in a different direction there. And I agree. I think one of the really important things to keep in mind is that even in a neighborhood where the poverty rate is 30%, I mean, 70% of people or households are not in poverty. And so I didn't show you any cuts today by whether the individual is in poverty or not. That's a really high priority for the next set of results that we're looking at, as are kind of looking at the interaction between race and income. Yeah, we have not done much on moves into poor neighborhoods. That's another big thing that's coming in the next set of results. Let me just say one more thing, because I basically agree with everything that you described as like good things to think about that we were doing. I just want to clarify one point on the place-based policy, because this is an area where kind of our thinking, I think, has been refined over time. You know, there's, I think, this idea that tagging benefits to somebody that's living in a poor neighborhood can be a good idea because you can learn something about that person's income or future consumption by virtue of where they're residing. I think nothing that I showed you today kind of undermines that argument. And so I just want to be clear that that is not the argument that we're making. And I think in a way, actually, like for the economists or the researchers in this room, this may not be kind of a mistake that people would make, but you know, it's just the simple fact that we want to point out is that basically living in a poor neighborhood today does not mean that somebody is going to live in a poor neighborhood therever after into the future. And so you want to basically be thinking about those underlying dynamics. I agree that there's still a lot of potential tagging benefits from providing benefits to people that are in these poor neighborhoods. And with that, I'll just say thanks very much.
now we have a 20-minute break, and we'll return at 4 for our last paper. All right, we'll start our last session for the day. Our paper presenter is going to be Gizem Kozar, and we're going to learn about subjectivity, uncertainty, and the marginal propensity to consume.
Thank you. Okay, I don't know if this is working, but hopefully you hear me. Okay, great, perfect. So since I'm the last, maybe I can thank the organizers for this amazing conference. It's been lovely to be here today. And I know there's also tomorrow, but just wanted to thank you. So this paper is together with Davide Melkanji, who's also at the New York Fed. So the usual disclaimer will apply. Okay, perfect. So, so in this paper, we're going to be interested in subjective uncertainty and the MPCs. The starting point was that, okay, labor income uncertainty lies at the center of the heterogeneous agent macro models. It is closely tied to precautionary savings and also exposed heterogeneity, meaning that people will have different MPCs. And MPCs in turn matter for understanding the effects of many macro questions, such as the effects of fiscal and monetary policy. However, despite the importance of earnings uncertainty and its relation to MPC, we have the empirical relationship has been very hard to test, and so we lack empirical evidence between the relationship between the MPCs and earnings uncertainty. And this is mainly because lack of data. So ideally, you would need individual-specific time-varying measures of MPCs and perceived uncertainty. Okay? So there's a large literature finding risk inferred from realized data, but potentially what matters for individuals' decisions will be subjective uncertainty, and this may well be very different from the risk inferred from realized data. On the MPC side, finding individual specific time-varying MPCs are very hard because it's very hard to measure MPCs. So in this paper, we'll try to kind of circumvent these data issues by using novel and unique data from New York Fed Survey of Consumer Expectations. So we'll be interested in the relationship between individual-specific uncertainty and the MPCs. And for these, we're going to use direct measures elicited from the survey. So for the year-ahead subjective uncertainty, we're going to use individuals' reported density forecast for their year-ahead earnings growth and spending growth. And for MPCs, we're going to be using their reported MPCs out of a hypothetical income shock. So because we only have 25 minutes, I'm not going to show you the spending growth expectation results, but I'll just mention it from time to time. So the first part of the paper will be about empirics. But even when we are looking at the empirical relationship, we'll be thinking about the standard incomplete markets consumption savings model. Okay? And after I show you the empirical results, I'll come back to the standard model, augment it with risk heterogeneity, and show you what the model predicts. I'll actually show you the model gets many things wrong, and then I'm going to look at some model variations and discuss why this model fails, and then what might be done to get a potential success to match the empirical findings. Okay, so let me briefly discuss the results. First of all, empirically, we document a hump-shaped relationship between subjective uncertainty and the MPCs. What this means is that we find that MPCs are increasing in subjective uncertainty for around 80% of the households, but then for households with very high uncertainty, MPCs decline. And this is true for both uncertainty measures, so both earnings growth uncertainty and spending growth uncertainty. And this relationship seems to be robust to a large number of controls. But what we find is that this relationship is driven by the cross-sectional variation. Okay? So when we focus on within household variation, the relationship disappears. So then we try to understand why this happens. And what we find is that most of the variation in subjective uncertainty actually reflects unobserved heterogeneity. So time-varying factors and preference heterogeneity or self-selection into risk are correlated with subjective uncertainty, but they only explain very little of the observed variation. Okay? So this is going to motivate our structural model, which will have exogenous heterogeneity in risk. So when we add this risk heterogeneity to the standard heterogeneous agent consumption savings model, we'll find that MPCs fall with earnings uncertainty in this model, but the model will be able to generate the increasing relationship between MPCs and spending uncertainty but for the wrong reasons. Okay? So then I'm going to talk about why this puzzle arises and then offer some potential solutions. Okay, so before I move on to the data, let me just briefly describe you the key forces in effect in this model that derives the relationship between uncertainty and MPCs. So here with uncertainty, I'm just thinking about labor income uncertainty. Okay? With higher uncertainty, the policy function, the consumption policy function will shift down, and it's going to be more concave. And this will mean that for a given level of wealth, the MPCs increase. However, increased uncertainty is also associated with increased precautionary savings, meaning there's going to be higher wealth, and then when you move along the curve, reaching lower MPCs. Okay? So ex ante, it's ambiguous which effect dominates. It's an empirical question. Okay. When we look at spending uncertainty, in the model, earnings risk heterogeneity will pass through to spending uncertainty, but due to consumption smoothing, the pass-through will be low. But there's this additional lever pushing for a positive correlation between spending uncertainty and the MPC. And that is coming due to the fact that in this model, lower wealth households have higher expected variance of consumption growth, which is the spending uncertainty. And lower households also have high MPCs. Okay? So this creates a third channel which pushes for a positive correlation. But once again, ex ante, it's ambiguous which effect dominates. Okay, I'll skip this, which is showing what I just described. Okay, so let me just describe you what the data set looks like and introduce you to our measures. So New York Fed Survey of Consumer Expectations is a monthly online survey which has been in the field since actually 2013, but most of the questions we use are from 2014. Every month we have around 1,200 to 1,300 household heads. It's a nationally representative survey. So we're going to use two measures, like I mentioned. The first one is a directly elicited question on MPCs. So it basically asks households to think that they're going to find their household with 10% more income than they currently expect. And then it asks how much of this windfall they're going to save, spend, or use to pay down debt. Okay. So since you're not asking questions, I can preempt some of the questions that are going to come. So we are aware that this question is not perfect. We're certainly aware of that, but we have a long time series for that. The problems with the question is that it doesn't specify this 10% income shock is a one-time shock. It doesn't specify that it's transitory, and it doesn't give a time frame for the consumption or for the behavior we're trying to elicit. So what we did two things. First of all, we fielded the version that we would want multiple times just to see how it compares to the MPC question that we have, and they line up pretty well. Okay, so it looks like the questions, at least most of the people are interpreting this question as a transitory one-time income shock, and then we asked for them to think about a 3-month time frame for the spending to save or pay down debt, and it looks like they're thinking about that. The second thing we did was that there are some papers out there. I'll talk about it when we come back to robustness. And then they ask about the MPC in different formats, and we use their questions to look at the relationship as well. Okay, so that's my defense. The second measure we're going to use is the uncertainty measure. So in the survey, households are assigned probabilities on various bins, that predetermined bins of year-ahead earnings growth rates. Okay, but this earnings growth rate is conditional on remaining on the same job. Okay, so they give us the probabilities with which they think their 12-month ahead earnings growth on the job falls between 0 to 2%, 2 to 4%, 4 to 8%, so on and so forth. So we're going to follow the literature and fit a generalized beta to this distribution and use the implied standard deviation of this density as the individual measure. So for each individual, we have one standard deviation. So for each individual, we have an uncertainty measure. So as I mentioned, this is conditional on remaining at the same job, so it doesn't capture all the risks you're facing, but in the model, we're going to follow the same approach as well. Okay, and then we have a similar question for the spending growth uncertainty, just asking for their year-ahead expected household spending growth, and then they again put probabilities to different bins, and we again fit a generalized beta. We also have a lot of other information. Okay, so I'm showing you a bin scatter without controlling for anything, of the MPCs on the earnings growth uncertainty. Okay? So there are 16 dots here, each representing around 6% of the sample. So what we see is that for the first 80% of the sample, there is an increasing relationship between MPCs and the subjective uncertainty, and then the curve starts declining. Okay?
So the MPC is like 50%?
Yes, out of 100. Yeah. Okay, so we can do this a bit more formally and just like estimate equations. So I'm going to show you different specifications all nested in this, but let me just describe you as I'm showing you the results. So here, just focus on the bottom panel. Okay, so the first column shows that even after controlling for observable household characteristics, the relationship is significant and quadratic between MPCs and uncertainty. The second column controls for expected earnings growth, just the first moment, thinking that maybe people who are more uncertain are also more optimistic, and maybe that's somehow kind of governing the relationship. We see that the relationship survives. The third column controls for year dummies, just to make sure that like whatever happening in the aggregate doesn't deriving both the MPCs and the earnings growth uncertainty in such a way, and the relationship survives. The last column adds net liquid wealth over income, and the final column adds individual fixed effects. So as you can see, once we control for individual fixed effects, the relationship disappears. We do a similar thing for spending growth uncertainty. So with spending growth uncertainty, you can think of it as the sufficient statistic for all risks the households are facing. Okay? So it does co-move with earnings uncertainty, and it's actually quantitatively as large as the earnings growth uncertainty, if not larger. Okay? So, which is kind of against the model. So what we see here is that we again have this like increasing and hump-shaped relationship between MPCs and spending growth uncertainty. I'm not going to show you the regressions, but the same story applies there. If anything, it's a little bit more increasing than the earnings growth uncertainty, and the relationship disappears again with individual fixed effects. So then we try to understand like why we're losing old relationship with individual fixed effects. So then what we realized was that, okay, it's because two sides of the equation are very stable. So MPCs are stable over time. Subjective uncertainty is even more stable. So one thing I should mention is that SE is a rotating panel, so we don't see these individuals forever. So every respondent participates for up to 12 months in the survey. So when we look at the variation in the subjective uncertainty, the within individual variation explains around 30% of the overall variation. Okay? So then we try to understand like what explains subjective uncertainty, and we see that observable time-varying drivers like income, assets, and age are correlated with uncertainty, but they only explain around 1% of the overall variation. Self-selection, people might self-select into different industries, and that is true. Some industries have different uncertainties on average, but we see very little action going there. Self-employed people and part-time workers have higher uncertainties, but again, these add up like by, I think, 1 to 2% of, they explain 1 to 2% of the variation. With preference heterogeneity, again, we don't find much. But if we put everything together, including like education, gender, like other household characteristics, all factors explain around 10% of the variation. Okay, so there's still a lot of variation that we can't really explain with the data we have. So we're going to just like attribute this to unobserved heterogeneity, and we'll just like use this in the model by just having an exogenous heterogeneity and risk. Okay, so I can just very quickly tell you that we tried many different things to see whether this relationship is robust. So earnings growth expectations are elicited nominally. So we thought, okay, maybe inflation expectations and inflation uncertainty might matter. Inflation uncertainty is very highly correlated with earnings growth uncertainty and spending growth uncertainty. But controlling for those don't change the relationship. We included, with job loss expectations, we did two things. We included job loss expectations as the uncertainty measure. And we also controlled for job loss expectations in our regressions, and the relationship survives there. You can use different definitions for subjective uncertainty. You can, instead of fitting a generalized beta, you can just assume this is the density, the probabilities that we see are just mass points assigned to the midpoint of each bin and create like a discrete approximation and use the standard deviation from that. The relationship survives, and it's the same. You can linearize the standard deviation, the uncertainty, thinking that these are elicited with measurement error. Again, we see the same relationship. You can get rid of people who put probabilities in the tails. That's fine. You can use IQR instead of the standard deviation. So these all, they don't change the broad message that we have. You can use different definitions of the MPC. The special survey is the one that we fielded that had like everything that we wanted from the question, and we still have the same relationship. You can use Fuster, Kaplan, and Zafar's version of the MPC question. There they ask, compared to the counterfactual of not receiving this money, how would you save more, spend more? It's a cognitively more challenging question, so they have less variation in their responses. But broadly, we have the same relationship there. The relationship we find is not coming from differences between single and married households, and then it holds across the household distribution for wealth, age, and different preference groups. Okay, so this seems pretty robust in the data. Okay, so now let's move on to the model. We're just going to take an off-the-shelf standard incomplete markets model, and we're just going to augment it with risk heterogeneity. Okay, so all we are going to do is we're just going to assume sigma is heterogeneous, it's exogenous, and we're going to calibrate the extent of that sigma heterogeneity to the SE data. So if you think about the bin scatter I showed you, we had 16 points there. I'm just going to assume there are 16 sigmas in this economy, and I'll just calibrate it to the data. So we calibrate data to the share of hand to mouth, and then the interest rate is going to be 1%. Okay, so the implicit assumption here is that we are under full information rational expectations world. Okay, so there is no misperceptions, nothing. So anything in the sigma I, like any heterogeneity in sigma, so uncertainty and risk, the realized risk is the same in this model for now. Okay, so if we solve the model, look at the stationary distribution and calculate the MPCs, what we find is this monotonically decreasing relationship between MPCs and earnings growth uncertainty. Okay. So anyway, with spending uncertainty, we do find an increasing relationship, but it's mostly driven by the low asset people. Okay, so now let's try to understand what's happening in the model that's generating the negative relationship. Okay, so on the left, I'm showing you the same relationship between MPCs and earnings growth uncertainty from the model, but this time conditioning on wealth. Okay, so there are 4 wealth quartiles here. And what you see is that within each wealth quartile, the relationship between MPCs and uncertainty are somewhat increasing. Okay? But this relationship gets flatter as wealth increases. So if you think about the 2 key forces that I mentioned, like the policy function effect and the wealth effect, within wealth quartiles, when there's like not much variation, there's like the policy function is dominating, but across wealth quartiles, when we look at it, wealth dominates. So when you look at across wealth quartiles, 2 things emerge from this figure. First one is that the curves shift to the right, which means that higher uncertainty is associated with higher wealth. And then the second one is that the curves shift down, which means that higher wealth is associated with lower MPCs. Okay? So now let's look at the equivalent of this figure in the data. And what we see is that, first of all, the curves don't shift down. Okay? So as you increase wealth, MPCs don't fall down. And then the second one, curves don't shift to the right. There's only a very locally positive relationship between earnings growth uncertainty and the wealth. Okay? So these 2 effects are going to drive the narrative for the next 6 minutes. Okay, so this is just, sorry for the typo there, but this is just describing what I just told you. In the model, we have a negative relationship between MPCs and wealth, and then a positive relationship between wealth and uncertainty, whereas in the data, we don't really see that, which gives us the opposite relationship. Okay, so then seeing this, we started playing around with what can explain what we see in the data. So the first thing we tried was to look at different calibrations. We tried around 810 different calibrations, and we weren't able to generate the relationship. Okay, so then we started looking at different variations of the model. Permanent income heterogeneity doesn't really add much because the model just scales up, so we get the same relationship. Life cycle model, we didn't want to try it because in the model, in the data, we see that this fact holds for all age groups, but nevertheless, we tried, we get the same relationship there as well. Endogenous labor supply doesn't change anything for reasonable Frisch values. Preference heterogeneity, so you can always cook up a preference heterogeneity in an ad hoc way that would generate the relationship that you want, but for meaningful values of preference heterogeneity, we couldn't get the relationship. And finally, we tried an earnings-based borrowing constraint instead of a hard borrowing constraint, and nothing changed either. Okay, so then we started thinking a little bit more methodically. So what we want to do is, it seems like the wealth effect is generating this whole relationship that we find. Okay, so then if you think about it, if you flatten the MPC wealth gradient, then maybe we can get this relationship. And there are two ways you can do it. You can either decrease the MPCs at the bottom of the wealth distribution, or you can try to increase the MPCs at the top of the wealth distribution. So for the bottom, we try two things. You can try consumption floors, or we have another paper with Davide where we kind of replace the hard borrowing constraint with an interest rate schedule that changes with debt stock. We augmented both of them with risk heterogeneity, but they're quantitatively too weak, and it only generates a local relationship. Then we then we focused on the higher MPCs at the top, which means that now we are moving into a world where we deviate from the full information rational expectations. Okay, so in this world, there are multiple things you can try. The first, most straightforward thing to us was to try mental accounting. So here, money is non-fungible, so people have different buckets out of which they spend. They can spend from their income bucket, their asset bucket. So it does actually this mental accounting model does raise the MPCs at the top, but when there is risk, the excess saving motive actually moves them out of the mental accounting behavior. So when stakes are too high, the households become rational in this model. So that didn't really help us. Then we moved into misperceptions. Again, so there are a couple things you can try here. The first thing we thought of was to try misperceptions about risk. So maybe people are thinking, this is kind of motivated by Victoria's paper with Andy Kaplan, where they show in Denmark that people realized risk and the subjective uncertainty are very different. So we tried that. In fact, they find that people underestimate the risk. So when we tried that, we find an even more increasing relationship in the data. Then Chandian has this paper where people don't know their wealth. And these future consumption mistakes actually raises the MPC. So we tried that, but the problem there is that the mistakes are exogenous, so you need to find a way to correlate that with the risk. And for monotonically related mistakes and uncertainty, we don't seem to get the relationship that we're looking for. And finally, we have the Ilut-Walchev paper where people have limited cognitive perception about their optimal policy function, which leads to two things. First of all is they are caught in learning traps, which means that they underaccumulate savings. And then secondly, when they're in an unusual state, they try to catch up with their optimal policy function, and then even at high wealth levels, they have locally very high MPCs. Okay? So we took that model, took their parameterization, and added risk heterogeneity, and what we get is this. So this is the first picture with a non-negative relationship, okay? So that we were kind of excited when we found this. But it's still not really showing what we're looking for, right? So here we see a flat relationship. It's actually slightly increasing at the low uncertainty levels. But if you look at it across wealth quartiles, it's still not really looking at what we are looking for, right? So still the very low wealth people have very high MPCs. And then there's still some shifting of the curves to the right. So there's this correlation between earnings growth uncertainty and wealth. So I'll just tell you this, the success of this so we used their parameterization, we didn't change anything, but it depends heavily on the two parameters they have, how uncertain people are about their optimal policy function and the similarity between the states. So, and we have no idea how to discipline them empirically, so you need to do some like lab work perhaps for that. Okay, so this is where the paper I sent to my discussant ends. But we have been very, very uncomfortable about the fact that this has been a puzzle paper, so we've been working on it, and we kind of discovered something last week. So if you look at the SCE, what you find is that here, if you look at the forecast errors of people on the vertical axis and look at their uncertainty on the horizontal axis, you see that low uncertainty people are over pessimistic. Okay? Whereas if you ignore that last point, for the rest of the distribution, they are not statistically different than 0, but for the lower uncertainty, we see this over pessimism. So we kind of added this to our model. We haven't done much. I just created these two figures. And what you see is that when you include that, you can get this hump-shape relationship. Okay, so that's just a teaser for now because this is all we have, but this is what we're going to work on for the hopefully next few weeks, and I'll hopefully let you know in the next iteration of the paper. Okay, so just to conclude in my last 20 seconds, so in this paper, we are interested in the relationship between subjective uncertainty and MPCs, and we show that this relationship is mostly increasing, but it's hump-shaped overall, and it's driven by the variation between households, leaving a large role for latent heterogeneity. And if you look at a standard heterogeneous agent incomplete markets model, we find that MPCs fall with earnings uncertainty, and that the reason why this is happening is because the wealth effect is dominating. And we think this was the same conclusion that I had before. I hadn't changed anything. We think there are marked deviations from the workhorse model is needed in terms of deviations from full information rational expectations to generate our empirical finding, and it seems like that's actually where we're going. Thank you.
Carol Blinder here to discuss the paper.
It's flashing red and green. Can you hear me? It's on? Okay, now it's on. All right. Thanks a lot for having me, and I'm really happy to discuss this paper. I've been working with this New York Fed data basically since the beginning. It's a really great service that the New York Fed provides, and it's been exciting to see how the survey itself has developed over the years and has become so useful. So yes, one of the key results is this first figure here, which shows that there's this hump-shaped relationship between earnings growth uncertainty and the marginal propensity to consume, or at least the reported marginal propensity to consume on the survey. And this hump-shaped relationship seems to be robust to controlling for observables. However, it totally disappears if you include respondent fixed effects. So that's important. The authors say much of the uncertainty perceived by households, as well as their consumption income sensitivity, are driven by latent unobserved traits. So one thing to keep in mind that I'll want us to think about is why that is, or what to make of that. And then the other is the big puzzle. So I also saw this as a puzzle paper. There's a puzzling relationship between net wealth and the MPC. So to remind you, in theory, and pretty much any theory that you can come up with that's relatively standard, you're going to have the MPC be higher for low wealth households and then lower for high wealth households. And they find almost exactly the opposite empirically. So that is puzzling and something I want to be also thinking about. So first, though, let me kind of give even more motivation for their paper than they provide in the paper. They write that the MPC and its heterogeneity are crucial for understanding the effects of fiscal and monetary policy, and that they've received a lot of attention in the literature. So there's a couple key examples of that attention in the literature that I wanted to point out. There's this important 2019 AER paper by Auclert called Monetary Policy and the Redistribution Channel. And in that paper, heterogeneity in the MPC is a key monetary policy transmission channel. the idea is that monetary policy redistributes from savers to debtors. And the key here is that savers have a low MPC. That's the low net wealth households have a low MPC. Debtors have, or savers would be the wealthy households. The debtors have a high MPC, so that boosts aggregate consumption. So okay, so heterogeneity in the MPC is indeed very important in this channel, but it relies on this fact, right, that the MPC is higher for low wealth households, which they don't find here. Similarly, there's another two important papers about MPC heterogeneity and the Great Depression. So MPC heterogeneity is actually very important in helping us understand both the severity of the Depression and the recovery. This is work by Josh Hausman, Rode, and Wieland. They show that the collapse of farm prices at the start of the Great Depression contributed to its severity. And this is because farmers who were debtors had especially high MPCs. So on the flip side, the recovery of farm prices after the dollar devaluation in 1933 boosted farm incomes. And again, because farmers had higher MPCs than everyone else, this led to a large increase in consumption and contributed to the recovery. So heterogeneity in the MPC was a key propagating and amplifying factor in the Great Depression. But why did farmers have higher MPCs in this story? Again, it's because they are in that low wealth quartile. They're the debtors. So Hausman et al. Say that the farmers in 1929 were like mortgaged US households in 2008. They had large debt burdens, so they had high MPCs. So, these two papers on the redistribution channel and monetary policy, and then on the farm channel and the Great Depression, both say that, yes, it's very important to understand heterogeneity in MPCs, but they both rely on this fact that, that there's going to be this strong relationship between MPCs and household net wealth, which we don't seem to find in the survey data. So it is an important puzzle. Okay, so what could be going on? I hope to never run 800 calibrations in my life, so I tried to come up with other ways to think about what could be going on. One is that MPCs, so as I'll explain, consumers could respond asymmetrically to income gains and losses. So MPCs out of income gains could be very different from those out of losses. Or there could be something else going on about this consumer survey data, how people report when they answer these surveys. So first on the asymmetric response issue, there's a paper by Fuster et al. And a handful of other papers, and they show that, yes, MPCs out of losses are very different than those out of gains. So this is from the Fuster et al. Paper, and you can see the distribution of MPCs when there's an income loss, right? They're a lot higher than when there's an income gain. And this is something that the authors could very easily do because the SCE has the exactly analogous question asking about, suppose next year you were to find yourself with 10% less household income. So they could easily just run all the same regressions using this measure of the MPC instead, this MPC out of income losses. Okay, and using this data, the MPCs from income losses are much higher. They're about 74% versus 18%. And within individuals, they're not consistent at all. The correlation coefficient is actually negative 0.1. So the results will probably be totally different. Here's the distribution, MPCs, the measure they were using, and MPCs from income loss. So only 1% of respondents would spend all of a 10% income gain, but 47% would cut spending by all of a 10% income loss. Another thing you should note here is that these are not kind of normally distributed distributions. They're very irregular, and that's partly because the way the question's asked, it's first a qualitative question, like would you spend it all, save it all, pay down debts, or do a mix? And if they do a mix, then they kind of give the shares. So anyone who says they'd like spend it all or save it all, right, they're going to be at the zeros or the 100s. And then the people who say they do some spending and some savings, a lot of them say, oh, it'd be 50-50. So you have this kind of irregular distribution. So that can lead to some, just interesting effects in the data because of the nature of people being on those corner solutions or saying 50-50. So I looked like by their earnings expectations, the share that say they would like spend it all or save it all or pay down debt with it all. You see relationships between the qualitative responses and earnings expectations means and also earnings expectations uncertainty. So the more uncertain people get about their earnings, they become more likely to say they'll spend it all and also more likely to say they'll save it all. Right? So that's maybe how you get some non-monotonic things going on there, and it would be driven by the zeros and the 100s. Okay. My next main point is like it's really important to understand the identifying variation here. Remember that the effects just go away when you include individual fixed effects. As a side point, I wasn't sure if these are actually year fixed effects or time fixed effects. I would have probably used time instead of year. But anyway, it's sort of like a philosophical question. What should we take seriously, the columns 1 through 4 or column 5? And usually you would include two-way fixed effects and take that regression seriously. So I'm having a little trouble understanding which one I should think of as like the real result. But if there is this latent heterogeneity that we're trying to understand, one source of that latent heterogeneity could be like people's preferences for how they answer surveys. So what I mean by that, one is like people have ideas about whether they're supposed to fill in all the bins or not when they're answering these density questions. So the modal respondent actually just uses one bin. So presumably they put 100 in there. But there's this sizable share that thinks they need to use all 10. And those are going to be, that's going to be like that last dot on all of those scatter plots. The people with the highest uncertainty are the people who think they need to use all 10 bins. Because there's this very close relationship between the number of bins that somebody uses and their uncertainty. That's almost by construction. And respondents are consistent across survey items and how many bins they use. So that could be like the latent heterogeneity is just like some people think they need to use all bins on, how many they use for inflation forecasts, home price forecasts, spending expectations. They're all very closely tied to how many bins they use for earnings. So I think this reporting preference could be what's showing up as latent heterogeneity. Some other comments, yeah, I think she already mentioned this, but respondents do only stay in the survey for 1 year, which I imagine earnings uncertainty is pretty stable over a 1-year period. So it could be that if you were able to survey people for longer, we might have more variation to work with. And then if I have some, yeah, I have a little bit of time. So people in the audience who haven't worked with this kind of survey data might be just wondering about the use of these vignette surveys or these hypothetical questions. Like, can people actually make sense of a question that says, imagine that this happens, what would you do? So I would just say that there is a pretty growing literature on the use of vignette surveys. Chris Roth and his co-authors have done a lot of work there, so you can see the paper by I'll say I have some work in progress with some co-authors where we were comparing what happens when you use hypothetical questions versus RCTs versus event studies to study the effect of a monetary policy but I think it also will depend a lot on the particular hypothetical situations, like how much consumers are able to understand it. Did I turn this off? Sorry. It's still switching from green to red. Okay, that's basically the end of my comments. I would just again say try with the other MPC measure, the MPC out of income losses, and then think about whether that latent heterogeneity can be coming from reporting preferences on the survey. And then also just that this is a very important question for, I think that paper about the Great Depression is one of the, the first kind of new theories of the Great Depression in recent years. So that makes it an exciting paper, which adds to the importance of this work. Thank you.
We're happy to take questions now. Marco, yeah.
So I was wondering, have you tried having liquid versus illiquid wealth or close substitute consumption commitments?
Oh, sorry. I am a fan of standard or simple heterogeneous agent models, but they actually don't fit the facts. And now there are versions of these heterogeneous agent models that are much more complicated. It's not a calibration issue. It's more of a what do you bring into the model issue that fit both the income distribution and the wealth distribution much better. And I would think to do this experiment, you want to have a framework where you match those things. However, so for example, to match the top end of the wealth distribution, people put entrepreneurship in the model. To match the bottom wealth distribution, people think about means-tested transfers. And when a model has all those complications, yes, it's harder to solve, but it matches the data much better. And then doing this experiment of MPCs in a model where it matches, at least in those dimensions, would be healthier, I think, instead of the simple heterogeneous agent model, because we know that that just was 1.0 heterogeneous agent model. So it is not expected to perform well in these questions, I think.
Yeah, this is related to a point that discussant. So you seem to, there is this puzzle of uncertainty MPC, but you seem to also another puzzle that there is this puzzle between MPC and wealth, and that in your data you seem to have MPC being higher for high wealth. But my reading, I remember, like, for example, there's a paper by Iapelli and Pistaferri. They use the Italian data, and that is very clear. So they have the same question that you guys have, and they rank it by wealth, and low wealth people have much higher MPC. So I was wondering, if you just do MPC and wealth in your thing, what do you find? Because is it complicated by the uncertainty, or is it just straight? Because if it's straight positive, that seems weird in the data. Yeah.
Any other questions? Okay.
Perfect. Thank you. Thank you for, okay, this is open, right? Thank you for the great discussion and also for the questions. I'll start from the questions and then go to the discussion maybe. We tried a model with like 2-asset model with liquid and illiquid wealth. We don't have, we still get the negative relationship because again, with risk, the liquidity increases and then the same channel seems to apply, so we couldn't generate it. We didn't try consumption commitment. We tried a very simple version of it, but we can talk later, but we didn't think that it would generate it, but we can definitely talk about it. A much richer model, I agree, that's usually the models that we work with, but we tried to kind of be very, we wanted to keep it simple and just try to see what we can expect from the model. And now we are going more complicated on a different end, so we'll see. But point well taken, and I'm completely on board with that. The MPC wealth thing, this also goes to what Carola was saying. So, because I'm showing you the quartiles, it's a little bit misleading. When you look at the relationship, it's actually, it's insignificant, MPC and wealth. But if you just like look at it in with different portions, one portion, it's a non-monotonic relationship, so it's like a little bit weird, but it's definitely not as what we have in the model. But I know what the data, Italian data you were referring to, that the particular years they are using has that exact same relationship that you talked about. But if you look at the newer years, they also don't have that relationship. So there's also some new papers that show that MPC and wealth relationship is a little bit different than what we've been seeing. I think there's a Greek paper that showed that the relationship between MPC and wealth is not exactly as we have in the data. So I think this is like a new, we can talk about it in survey. There are many different things that might be affecting why we're getting this result, but I think also in realized data, we are getting some MPC and wealth relationship that is not exactly as we have in the model. So going back to the discussion, the first thing I'm going to say is that in the model, the MPCs, we calculated the same way as we have in the data. So we did a 10% positive income shock. And with the concave, you took like concave policy function. In the model also, the positive and the negative MPCs are not the same. And what you showed was they were exactly mirror image of each other. So actually, that's very consistent with what we want. So you also mentioned that we have a filtering question for the MPC. There's a new paper by Tom Crossley. They're showing they did some experimentation, and it looks like when you don't include that filtering question, actually you get very nonsensical responses to the MPC questions. So I think having that qualitative question is very important. And when we calculate what I showed you for MPCs, include those people as well. But we get the same result without those as well. And what else? 10 wins. So earnings growth uncertainty. So earnings growth expectation is one of those questions where actually people are they're very good at knowing like what their earnings are gonna be, because like this is conditional on remaining at the same job, especially like if you're a salaried worker, you are very people just put in one bin because that bin has like 2% difference. So usually you know like whether your income is gonna be between income growth is gonna be between 2 to 4%. Yes, there is some mechanical effect, like the number of bins are correlated with the uncertainty, but it doesn't mean that the person who puts like a mess in every bin is the most uncertain, because you can think of it as they can put 90% in one bin and just like 1% or like 2% in the others, and that won't be the most uncertain person, that will be a very certain person. You mentioned that, yes, we have the issue of a small panel, which is true. There's, I think, a new paper showing that the volatility in earnings is mostly at the monthly level, so from month to month rather than year to year. So that I thought that was like kind of helping us a little bit. And the vignettes. So for the MPCs, I think there's a lot of evidence, especially for MPCs, showing that the revealed preference and the hypothetical MPCs line up quite well. We also have some other work showing that the hypothetical MPCs here line up, and the heterogeneity in those line up very well with the MPCs out of stimulus checks. So I think on that end, like this type of particular question is pretty useful. And in comparison to Fuster, Kaplan, and Zafar, it's a very different type of question. I think the question that I mentioned you, like how much would you save or spend or pay down debt out of the windfall, is a little bit easier to understand. And I think the Shapiro, Slemrad, there are like a series of papers showing that that is predictive of what people actually do ex post. So the ex ante MPCs line up with ex post. So I think this is a more robust version than the Fuster, Kaplan, Zafar version. And anyway, so that's all. We can talk later. But thank you so much. Yeah.
Hello. This works. Can you hear me? Yes. My name is Andrea Raffo. I'm the research director here at the Minneapolis Fed. It's my pleasure to bring this day to a closure. I know I stand between you and reception, so I'll be quick. I have only 2 announcements. First, I wanted to extend thank you to all the participants to this great event. First, starting from our keynote speaker, Professor Card. David, you mentioned over lunch that you actually visited rarely the Federal Reserve Banks, and this was your first time in Minneapolis. Let me try to fix that. You have an open invitation to visit anytime you want in the future. Then, thanks to all the participants, presenters, and discussants, I thought that the participation from the whole room was great. We had a fantastic exchange of views and questions and answers. So there was definitely an energy throughout the day until the very last moment. I felt a little bit bad for her that she was receiving question over question, even 5 p.m. in the evening, but it's just the energy of the room that I'm very thankful for. Some people couldn't make it, unfortunately. We started yesterday with a meeting with the advisory board of the Institute. Today was the flagship day, but I'm glad to share that obviously the event was live streamed. People have been following. We got a number of questions actually from the audience. And the proceedings are going to be available on our website. And with that, let me go to a list of thanks for people that made this event possible. There is a lot of work that happens behind the scenes. We're going to conclude this event, and then starting next week, we're going to start brainstorming about next year. So it takes quite a bit of time. Let me just acknowledge the work of all the contributors to this event. First, by thanking the committee that put together the program. And Amanda, if you please stand up, we're going to give you a round of applause. Amanda, Serdar, Daniel, Taha, Steffi, and Kohali. Then many other individuals actually helped with the logistics and putting together everything that makes such an event successful. I see you in the room. Please stand when I call your name. Alexander, Susie, Lisa, Jordan, Victoria. And our sprinters are raised that have been going left and right with mics. Journey, Richard, and Zoe, please. Thank you. And last but not least, our tech team, our PA folks, we actually got quite a few media participants to the event, and obviously our law enforcement units that facilitated access to the building. Thank you all for facilitating and for helping us with this event. Yes, an applause for them too, please. And last but not least, thank you, Abby, for the leadership that you are showcasing every day for this group. And this has been another fantastic event organized by the Institute. This is now the version number 8 of this, or 6 of this conference. How many did we have? 5? But basically, fantastic work. They're always super successful, great attendance, and I know that you play an important role in putting together the work behind this event. So thank you for your leadership. Final thought. As I said, there was a great amount of energy and exchange of ideas. These conferences now, all the researchers are used to disseminating their ideas, getting feedbacks to making the papers better. I actually want to emphasize that there is an aspect of serving the public that is behind events like this one. It is super important that the research doesn't stay just in academia, but actually reaches a broader audience. And I like to think that the technology like live stream and here in the Fed, I think has a unique position in terms of playing the liaison between the academic world and the public. I wouldn't underestimate the importance of disseminating research beyond just the academic community. And I like to think that what we did today was a small contribution to that. And I thank you for your help. With that, enjoy the rest of the evening.